Ladies and gentlemen, welcome to your penetrant testing level 1 training. Right? You will be here for 3 days from Tuesday 14, 15 and 16. Yeah? That is Thursday until Thursday. Then you will have your initial level 1 PT examination on the 17th on Friday. So our training will be quite intensive. We'll cover your theory. Half day we will cover theory. We'll go through the theory regarding penetrant testing process and what requirement to perform this testing. Then in the afternoon, around 1:30 like that, we will start our practical. So you need to have hands-on as well because your examination will include both theory as well as practical. Okay. So to start, let me just introduce myself. My name is Stephen Leong. I've been with Testia as a Pacific for the past 3 years plus. Prior to that, I was with Malaysia Airlines. Then I joined Emirates in Dubai. Then I'm back in 2019, just before COVID-19. I joined Subang Aircraft Engineering. So while working with Subang Aircraft Engineering, Testia as a Pacific was having project with SAP. So because both were under the Airbus, Testia as well as Subang Aircraft Engineering were under Airbus company. Then when the project of training launched, they advised me just to join them. That's why I've been training for the past 3 years plus. Right? So happy to have you, especially from representing Thailand, to come to Malaysia for this training. We're always excited to have overseas students to join us. So maybe just a short to introduce yourself, your name, how long have you been with the company, and what do you have you done anything else besides penetrant testing? Okay. Maybe start with you. Say your name, your Thai's name.
Hello, my name is Osborne Magan. Call me Seth. Call me Okay. I'm a MEP technician.
Okay. So how many methods have you been involved in NDT?
2 methods.
2 methods. So eddy current as well as penetrant testing. Okay. Thank you. Hope that you will enjoy the training. What about you?
Hello, my name is
Okay. So how long have you been with the company? Okay. Thai Vietjet Air. How long have you been in the company? 3 months. Wow, very new still. So how many NDT methods have you involved so far? How many NDT methods? 2. Also eddy current and penetrant testing. Okay, that's good. That's good. But this actually is a very useful combination. Most of the MRO activities, the big volume will involve eddy current on structure, and then for component-wise in the workshop, you will require penetrant testing. If you are talking about wheel and brake shop, eddy current and penetrant testing will be a good combination. I hope you will be enjoying the class, and then when you come for the examination on the 17th, of April, this Friday, everything will go well. So let's start looking at this liquid penetrant testing. You are attending liquid penetrant testing level 1. So level 1 is only for 3 days. The actual requirement is only 16 hours, but your company, responsible level 3, suggested that we cover it in 3 days. You can see 3 days is already very rushed, and the minimum requirement is actually 16 hours. It's super rush, because you also have to cover 3 components. Normally level 1 may not cover all the anyway, with additional 1 day, we should be able to do it if you bear with me, as well as follow the speed that we're going to go along. Yeah? Let us just go through some of the chapters we need to cover for theory. That is general, and then we will need to cover chapter 1, introduction to liquid penetrant testing. Chapter 2, properties of penetrant, and then chapter 3, surface preparation, and then chapter 4, penetrant testing methods, chapter 5, penetrating process, and then chapter 6, inspection, chapter 7, typical indication, and then chapter 8, defect sizing, chapter 9, quality control, chapter 10, work instruction and report. Then chapter 11, 10 common misunderstanding of penetrant testing. Alright? The chapter 10 we will skip partially because work instruction is not required by your responsible laboratory. But we still need to look at how you do reporting. Yeah? So we will partially cover chapter 10 mainly on reporting, but not written instruction. If you were to come back for your level 2, then you normally need to know how to write written instruction. That means instructions, step-by-step instruction, detailed processing, how you were to perform one component, to perform, let's say, penetrant testing method A. So you must be able to write simple instruction for a particular component as your competency requirement. You follow? Yeah, but your level 1 at this stage, you are exempted from doing the work instruction. So we will skip that later on. Yeah? So hopefully we will do it in so-called according to this sequence, and then after that we will at each stage we will have also phase tests for you. Yeah? In total of these 11 chapters we need to cover, and then we need to cover 4 phase tests. Yeah? So it will be in stages. When we finish our theory, then we will do your phase test, and then we will also do your phase, your practical, and then the practical will involve report writing. Yeah? All these need to be submitted because it is a training package as a record for the certification issued to you later on. Yeah? So without further ado, let me start with introduction to penetrant testing. So, do you know what is non-destructive testing? NDT. What does NDT stand for? Yeah. Yes. Method of assessing or evaluating material or structure without causing damage. Very good. So this should be something that you need to remember. The keywords here is that technique or test method used in various industries to evaluate the property of a material, component, structure, system without causing damage. So the keyword here is without causing damage. Yeah. I hope you can remember at least testing on component, structure, system without causing damage. So that will be the summary of what NDT means. Yeah. Alright. What are the NDT methods we have here? The most common NDT methods we have here include penetrant testing, short form PT, magnetic particle testing MT, radiography testing RT, thermography testing TT, ultrasonic testing UT, and eddy current testing ET. So these are the most common ones. Outside of this group, there are also many others, such as spectrography testing, acoustic emission, right, and so on and so forth. But the most common for us in the aviation and classified as the most common under the EN4179, that is a certification for non-destructive testing personnel for aerospace industry. These are the 6 plus 1 more, that is xerography. Yeah, even the standard has changed a bit. Previously, they have 6 methods as common entity method. Now they have, at one time they include xerography, at one time they remove xerography, but recent one they add the xerography back. So in total there are 7 common entity methods. So imagine if you are qualified in the 7th entity method, you are the one of the most qualified around. Yeah. So you are still younger for you. If you were to qualify in this called 7 method, you will be very highly in demand. Yeah. So maybe set your ambition to get as many as you can. All right. And then one day you will be successful because you have multidisciplinary entity qualification to support the industry. Right. So in conclusion, NDT means a means of evaluating a parts of material without destroying or altering the parts of material in any way. And because of that, parts tested under NDT, you can return back to service. And that makes the NDT very useful and sought after because it is an important part of the ecosystem for MRO. Without NDT, airworthiness you cannot ensure, and then safety, flight safety will be, cannot be guaranteed. Yeah? So that's why good that you have attended, good that you can attend this year. Alright? So we will stop here. For introduction. Then we will move on to our revision. I don't want to take too long of your time, but I'm caught in between. Anyway, what do you need to know that we have studied earlier? Yesterday? So good morning. What have you learned yesterday? We have learned up to which chapter? Chapter 4. Yeah, chapter 4. So we quickly go to chapter 3 just to see whether you still can remember the properties of penetrant, yeah? By way of revision before you go for your face test. Okay. Maybe we just touch on the classification of penetrant material. So remember, yeah? So remember penetrant, yeah, has 2 classifications, type 1 and type 2. Type 1 is for fluorescent dye, type 2 is visible dye. And then penetrant also can be classified into 4 different methods, depends on how you remove the excess penetrant from the surface. What are the 4 different methods? Method A, method B, method C, method E. A is water washable, B is post-emulsifier lipophilics, and then method C, solvent removable, method D, post-emulsifier hydrophilics. Okay, besides penetrant, you have also in terms of type of dye, way of removing excess penetrant, you have also penetrant classified under different sensitivity levels. So in total there are 5 levels, the lowest being level half, also known as ultra low. Then you have level 1, which is low, level 2, which is medium, and level 3, which is high, and level 4, the highest of sensitivity is known as ultra high. Yeah, ultra high. Then in terms of developer, okay, the developer you can classify developer under 6 category. For dry powder, it is known as form A, and then water soluble form B, water sustainable form C, and then non-aqueous type 1 is known as form B, and then non-aqueous for type 2 known as form E, and lastly for special application it is classified as form F. Okay, 6 category in total for developer. Now, for remover means you remove the excess penetrant during the method C, solvent removable. Can you see that? Solvent removable, you need remover. You also use remover to do pre-cleaning or post-cleaning. Alright? But for method C, you also use remover to remove excess penetrant from the surface. What are the classes we have for the remover? There are 3 classes. First is halogenated, second is non-halogenated, and class 3 lastly is special application. What is halogen? Do you know what is halogen? Yeah. If you study chemistry, under the periodic table, the group 8 is considered halogen. Yeah, consists of chlorine, iodine. All right, these are the material or elements that can have adverse effects on metal. Example, chlorine, if it is have residue on engine component, if it is subjected to the very high temperature, and it can cause embrittlement on your material, and that is not good. So that's why if you were to perform inspection on component made from titanium as an example, you need to choose to use remover that is class 2, because class 2 will be remover without halogen as their formula. As their formula. That's why it is important to have knowledge and follow procedure for titanium component. Class 2 must be used. Right? And then another concept we need to understand is regarding system, penetrant system. A penetrant system consists of penetrant, emulsifier. Some documentation will say developer, but some documentation will consider a system of penetrant consists only penetrant and emulsifier. Yeah? So you need to understand different document will classify it slightly different, but it is safe to say that a penetrant system consists of penetrant and emulsifier. Right? It is something like a family concept. That means you have parents, you have your children, right? Parents and children. So if you were to use the penetrant from one manufacturer, then your emulsifier must be from the same manufacturer as well. So that is what it means by family concept or penetrant system. The same manufacturer you need to use for their penetrant as well as emulsifier. You should not use from some other manufacturer because their formulation will be different. They will behave differently. That's why penetrant system is very important. Okay? We will stop there. Yeah? And we will move on to Chapter 2. Chapter 2. You still remember? This is by way of revision. What are the properties for a good penetrant? Surface tension. So for a good penetrant, what type of surface tension is required? Do you require high surface tension or low surface tension? Low surface tension, that is correct. So if you were to have the good penetrant property, the surface tension of the penetrant must have low surface tension. It must have low surface tension. What about contact angle? Contact angle is actually related to surface tension. So if I have high surface tension, my contact angle will be high, but normally higher than 90 degrees. The line will be the tangential of the contact between the liquid to the surface of material, right? So it's higher than 90 degrees. So for a good penetrant, you will need contact angle that is low. That's correct. Low surface tension and low contact angle will give you a good wettability. Understand? Good wettability. That means if you pour a small amount of penetrant on the surface, it can spread out evenly. So it wets the surface evenly. That is called good wettability. We have touched about wettability, alright? Because it is linked to these two properties that we have covered earlier. What about capillary action? What about capillary action? What is the ability? The ability of a material or a liquid to enter narrow space. Remember, if you put a straw in a glass of water, you can see the water will rise higher to a higher level than the level of water in your cup. So why? Because capillary action has taken place, right? So in fact, the capillary action works in a way that against the gravity pull, right? Gravity pull it down, but the capillary action can go against and it rise up higher level in the straw that you have put in a glass of water. Okay? What about viscosity? What about viscosity? Yeah. Ability to penetration. There is certain difference here. If you are talking about viscosity is ability, then it's a wrong understanding, right? If you remember, it has to do with rate of penetration, how fast it can penetrate. Yeah, viscosity is related to how fast the penetrant can penetrate into the discontinuity. Whereas ability to penetrate will be capillary action, wet ability, these two, right? Because of wetting ability, which is related to the first two, surface tension, contact angle, wettability and capillary action is the ability of the liquid to enter a discontinuity. Whereas viscosity is the rate of penetration. How fast? If you have high viscosity, high means it doesn't flow that fast. Example like honey, you want to pour it, it will be a bit sticky and takes longer time to drink. And that is high viscosity. High viscosity will have lower rate of penetration into opening of a discontinuity. Follow? If you have a good rate of penetration, then you need to have penetrant with lower viscosity. If you have understood that behavior, then if you were given a scenario, a condition, let's say I am having a higher temperature. My component, I warm it up at higher than room temperature. Then I apply my penetrant. What happened to that penetrant viscosity? Would it be higher or would it be lower? At a higher temperature, what will happen to the viscosity of the penetrant? Should be lower because just like you warm up certain gravy, your food gravy, when you warm up, it tends to active, right? The molecules become very active, so they are actually less viscous if the temperature is slightly higher, right? If that is the case, then your rate of penetration will be higher. So at slightly higher room temperature, you will get higher rate of penetration. But you also must be careful because penetrant is made from oil-based chemical plus some volatile chemical. Volatile chemical means it can evaporate. Right? If you have subject the penetrant under heat that is high as well as a long period of time, the volatile composition will evaporate. Then what will happen next? The viscosity will be higher. Okay? When viscosity becomes higher, what happens? The rate of penetration becomes lower. So you must aware, depends on the condition. Right? On the slightly elevated temperature, your viscosity should be lower. But if you have subject the penetrant to a long period of high temperature, your volatile constituents evaporate, then it becomes high viscosity. Then rate of penetration will be lower. So if you can understood, grasp this principle, many questions will be around that. You follow? Very good. Alright. So we also have a look at this one. Right? Surface tension, the boatman on the water surface, it doesn't sink because of the high tension surface tension on the water. So the high surface tension of water supported the boatman and not sinking into the water. Okay? Then we also talk about example, right? High surface tension will have the appearance of puddles, some dry area, and then some water spots. Well, so good or low surface tension liquid, it will have an even separate of the liquid on the surface. So low surface tension equal to wettability, and this is what we need for a good penetrant. We also talk about contact angle. High surface tension liquid, if you drop it or put it on the surface of a material, it will form like a globe and then give you very high contact angle, more than 90 degrees. And for low contact angle liquid, because of the spreading evenly on the surface, it will flatten and the contact angle will be less than 90. Right? So low contact angle gives good wettability. Now capillary action, we also mentioned that like a tissue, right? If tissue itself, because it consists of fibers and empty space in between the fiber, if you bring the tissue close to the a drop of water, and it will raise up against the gravity pull because of capillary action. Okay, viscosity. Right? If you try to pour high viscosity liquid, it will be slow flow out, such as honey. If you flow water, it will be very fast. You can see the difference. Yeah? Right. Low viscosity liquid will flow easier, and then high viscosity thicker liquid will flow not so easily. such, low viscosity is related to rate of penetration, how fast it can enter the opening of a discontinuity. Okay? Alright? Alright, we have finished. Then, in the form of revision, what about surface preparation? Before you perform penetrant testing, you need to make sure you prepare the surface of the component. Contaminants on the surface must be removed and ensure the surface is dry. Correct? We have mentioned about what is the most common contaminant in the penetrant testing. What is the most common contaminant when we perform penetrant testing? Is it oil, or paint, or oil, or which one? Can you see this? Water. Remember? Water is the most common contaminant in penetrant testing because water is the most commonly used during your pre-cleaning. The pre-cleaning, if there is any carry on from your previous cleaning process, the water is the one that is going to contaminate your surface and your penetrant inspection. Follow? Alright. So there are many types of cleaning, mechanical cleaning, and then we also talk about solvent cleaning, vapor degreasing, aqueous cleaning, high pressure cleaning, ultrasonic cleaning, mini raster or paint remover, etching using acid or alkali. Remember, which is not recommended, especially on certain metal that is soft, such as aluminium or magnesium. You have a component made from aluminium or magnesium. If you were to subject that component using mechanical cleaning, what happens? It will smear. Remember the words smear. Just like I use peanut butter, the bread, I spread it out. It just smeared the surface of the bread, right? So it has that effect. The mechanical cleaning, because of the force and the hardness of your medium, it can cause the thin layer of the metal to cover over your discontinuity opening. If this happens, then penetrant will not enter. If penetrant will not enter the opening of your discontinuity, you will not have the ability to detect the presence of discontinuity. Right? That's why if anyway, every times you truly need to do the mechanical cleaning. If mechanical cleaning is allowed, there will be one more cleaning process required that is called etching. Remember, if you have somehow you have to do mechanical cleaning, if it is approved in your maintenance procedure, then normally they will add one more steps, that is etching. Only then you can do penetrant testing on the part. Okay. So which one is the most common one? Solvent cleaning, especially when you perform in situ inspection. You use solvent cleaning because it's portable. You use aerosol can to spray on the lint-free tissue and then wipe it on the surface to remove organic contaminant from the surface before performing penetrant testing. And then vapor degreasing, right? One of the very effective cleaning process. In this process, we also look at the typical machine, how the arrangement look like, and then the component is placed in the vapor region of that liquid solvent, right? And because the arrangement it is effective, there is additional advantage because do you need rinsing after putting your component for cleaning under vapor degreaser, you don't need rinsing. Right? Rinsing is not required after vapor degreasing. You follow? Then aqueous cleaning. Aqueous cleaning is basically just your dishwasher. Alright? So mainly you use water to clean your component. And then that water can include a small amount of volatile organic compounds, or sometimes will be added with detergent to remove those contaminants from the components prepared for penetrant testing. Okay? So it will associated with heat agitation, that means the nozzle with water spray, high pressure, high temperature, and then mechanical movement to break the dirt into small particles and then wash it away. So that is the aqueous cleaning. Right? High pressure cleaner, basically just like a car washing shop where they have a high pressure nozzle together with high temperature, and then to remove the dirt by breaking it into small particles and washing it away. Yeah. And then we also talk about ultrasonic cleaning. This is one of the most effective cleaning because it is a combination of vibration at frequency between 20 to 400 kilohertz, and then a suitable cleaning solvent to remove the contaminant, and with the actions of vibration, and add on with the temperature between 50 to 65 degrees Celsius, it is effectively remove dirt from the component before you perform penetrant testing. So the commercial, you can come across ultrasonic cleaning appear in what shop? Gold shop, right? The gold shop, if you have a jewelry that has come down, you want to polish it, clean it properly, the gold shop normally they will have this as well. Then paint remover, you remove paint from the component prior to penetrant testing, because penetrant testing cannot be performed with coating on the surface. Yeah, so we need to remember that. And then it is highly corrosive. It is a health and safety issue, and not so friendly to the environment. So when you perform paint remover operation, you need to make sure you wear PPE, personal protection equipment. Yeah, follow the local rules and regulations, and then observe how you throw away the waste of your paint remover. Right? So first you ask, are you protected when you perform this paint remover process? And what about specific hazard associated with each paint remover? Each of them may have different requirements in terms of corrosiveness, in terms of impact to the environment. We need to be careful and then observe the requirement. Refer to what? If you want to know more, refer to MSDS. What is MSDS? Material Safety Data Sheet. Yeah, remember? Material Safety Data Sheet. Prior to usage of any chemical, you should always refer to MSDS. Okay? Right. Last, we also touch on etching, right? How it can be performed. Why etching is required? Because etching will remove the smeared metal and open up again the discontinuity opening, and that will allow you to detect any discontinuity if you perform penetrant testing, right? So, in fact, some of the procedure require you to perform pre-penetrant etching, especially some engine parts, because some engine part has a moving parts, right? Moving part, if metal to metal you rub against each other, the chances is that there will be metals smeared on the surface. So even though you have not performed mechanical cleaning, the component of certain function in the engine, when it is undergoing overhaul, it will need to be etched first before you perform penetrant testing. So there may be a requirement in your engine maintenance manual, certain component they will say clean, then etch, only then penetrant testing, because of the operational condition of the component. Follow? Yeah. Drying is very important. If you do not perform drying properly after the cleaning process, if it is inside your discontinuity, it will block and do not allow penetrant to enter into it. That's why drying is important after cleaning, to make sure there is no water in the discontinuity. So when you apply the penetrant can enter into the discontinuity properly. Right? After you perform the penetrant testing, you must perform post-inspection cleaning. Why? Because residue of your penetrant material can be corrosive. If not removed properly, it will attract moisture and eventually cause corrosion. Okay. Likewise, if it is not removed properly, if you were to perform subsequent process such as plating on the component or painting on the component, the residue will prevent good adhesions of your coating or your plating, and it will cause damage shorter than it should, such as here. Paint plating after a short period of time because poor adhesion taken place. Moisture in the residual penetrant material after some time will cause corrosion. Right? So how do we do post-inspection cleaning? The most common one being vapor degreaser or aqueous cleaning, which we have mentioned and then discussed about it earlier. Alright? Last is about penetrant testing method. This is chapter 4, we have discussed about this. And how many steps for method A, water washable? How many steps? 6. That is very correct. So you have clean, apply penetrant, remove excess penetrant, then you dry, and then you apply developer. When you apply developer after drying, it is about what type of developer? 2 types. Dry developer and non-aqueous developer. So the process of drying before applying developer is applicable to 2 types of developer, namely dry developer and non-aqueous wet developer. Okay? If you are talking about form B, form C. What is form B, form C? Dry developer is known as form 1. Very good. Then non-aqueous wet developer is known as form D. In between form B and form C, one is water suspendable. The B is water soluble. C is water suspendable. So water soluble and water suspendable developer, the drying is the other way around. You apply the developer first, only then you dry. You follow? So that's why I need you to aware these steps is correct when you apply developer that is of form A or form D. You follow? But if you were to apply form B B or form C, then you have to apply the number first, then only dry, then you do your inspection. Okay? So, but anyway, because form B and form C is very rarely being used in aerospace. It is being used. I have seen it in a landing gear shop. They apply the form C. Form C, water suspender. I have seen it before. Yeah, but in general, most of the MRO they will adopt or use dry developer or non-aqueous vacuum. Okay, all right. 6 steps. Very good. What about method B? Post-emulsifier lipophilic. Lipophilics is the emulsifier is in the oil-based form. Because it is oil-based, you do not need to dilute it. Remember? Yeah, you do not need to dilute it. You can use as it is. You purchase it. It comes in the drum, in the original concentration. You apply it straight without any dilutions required. So, how many steps? How many steps? 7, because there is additional step that is called apply emulsifier. Alright, in these formulations, method B, your penetrant does not have any emulsifier added into it. That's why in the process itself, you need to apply emulsifier to make it washable. Follow? Make it washable. For this type of lipophilic post-emulsifier method, you do not have any process between apply penetrant and apply emulsifier, and then the rest of the step is the same. Yeah. So additional one step is between apply penetrant and remove excess penetrant. You need to add one step that is called apply emulsifier. Follow? Next, second one or the third one that we are going to consider is method C, solvent removable penetrant testing method. So, how many steps? 6. Just like method A. Yeah? Just what is different between the removing excess penetrant? In method A, you use water spray. In method C, remove excess penetrant, you will use tissue paper that is leak free. That means the fiber is not easily loosened, alright, and then you will use solvent, alright. You damp your tissue to remove the final wiping off of your excess penetrant on the surface. Okay? Otherwise, the rest is the same. Yeah? Doing the same process. Next, last is a method D, post-emulsifier hydrophilics. I have mentioned hydrophilics is water-based. Water-based, just like detergent. At home, when you buy your detergent to wash your dishes after your meal, sometimes the concentration is very high. You can add water, am I right? Same. So, these water-based hydrophilics come in a drum, highly concentrated. Right? You need to dilute it. That's why once you have diluted it, you need to ensure it is of certain concentration, percentage of concentration has a limitation, not above certain percentage of concentration by volume. Example, some product will say, okay, maximum concentration is 10% by volume. Some may be 20% by volume, depends on which product you are using. So you need to follow the instruction. The maximum concentration, if it is 20, you make sure you do not go beyond 20. How do you ensure the concentration is correct? Using what? Some it out, reflectometer. Remember that because when you are young, it's good to remember those important equipment that you use. It's not difficult, but sometimes you just take time to remember. So it's good if you can remember early. It's called reflectometer. Yeah, reflectometer. Basically, we have not done yet. Today, during the practical, we will go through it, how we do it. Basically, once you have mixed your hydrophilics emulsifier, you will take a drop and then put it at the surface here and close the cover and then view it. When you view it, you will see a clear demarcation, a line between upper and lower. Upper is actually in the blue color, lower will be in the white color. The transition, the line that is marked clearly between blue region and white region, that is the reading you have to take. And that reading is actually the concentrations of your hydrophilic emulsifier by reading from refractometer. Remember, I mentioned to you, which we will demonstrate today in the afternoon. You need to refer to your graph of refractometer reading versus percentage of concentration. So from this reading that you have obtained, you draw a horizontal line. Let's say my reading is 15. I draw a horizontal line across the graph, and then at that line of concentration, I will read down vertical down. That will give me a percentage of concentration of my hydrophilics emulsifier, and that is the one that I should record down. Right? All these are called quality control. This quality control need to be recorded down in your form, yeah, as qualifying you to proceed with your inspection for the day. Right? So far, okay? All right, good. Then, how many steps here for this method D? 8, correct. Additional of pre-wash. And then apply emulsifier post-wash. The rest will be the same. Pre-wash basically just to remove the excess penetrant, to remove most of the bulk of excess penetrant from the surface. And then you apply your emulsifier, hydrophilic emulsifier. After a stipulated time, you will wash it. Yeah, wash it under UniKL light. So basically, we have talked about this yesterday. Good that you still can remember. And then any question, because we have concluded our division in a quick manner. Hopefully that help you to remember the things that we have covered yesterday. Right? If you have any question, please ask. Otherwise, we will have to do our phase test. You have to do your phase test number 1 and number 2. Yeah? Alright? Are you ready? Should be okay. Yeah? You try. As I mentioned, phase test, you don't ask your friend. You can refer back to your notes, right? Make your decision. And if you have no issue, good. If you have issue, we will go through it in form of, in the terms of to additional counseling or to revise again to make sure that particular gap is being closed. Right? If you have no issue, you can take one and then fill up your name. Do the same thing that we have done earlier. Can I just have your practical booklet? While you are doing that test, I will mark your report that you have done yesterday. Yeah? Oh, these are extra, sorry. Okay? Any question you can refer to me. Yeah? Alright. face test number 3 and 4 tomorrow early in the morning. Yeah? Finish, then you submit to me, I put tick mark, and then we can discuss. Finish? Okay, thank you, me. You can take a short break, alright? Come back in 10 minutes time. We will go over or review some of the theory that we need to cover, right? Close the gap. But since both of you have gotten more than 70%, you don't have to go for the counseling. Yeah? Anything that you want to discuss? Be careful during answering. Some of the question is a catch. They say which one is not. When you mention not, then you have to answer negative answer. Yeah? Which one is not correct? So you have to be careful of the answer. What they ask. Something that is opposite of the norms. When they say not, which one is not? Then you have to read carefully and answer carefully. Otherwise, you have done well. Can you see that that is not? Yeah, that is what you need to be careful. Okay. Right? Okay? Happy? Anything to clarify? You know where you have done a mistake if you got the answer wrong? How about this question? Question number 11. Which of the below listed penetrant methods the most easily overwash? Yeah. Method A. Reason because it has emulsifier inside. When you have added emulsifier, if you spray it with water wash, you can just wash it off. So that's where your correct timing of washing is very important. Whereas PE, post-emulsifiable, because you have to apply the emulsifier. Right? If the penetrant doesn't cover by emulsifier, it will not be able to wash away. It's more difficult to wash away. So PE, post-emulsifiable, the reason why they have an additional step of applying emulsifier is to control so that those penetrant that is in the discontinuity will not easily be washed away. Unless you allow the emulsification time too long, then emulsifier will go in and then cause it to be water washing. Right? You get it? Yeah, hope you get it. So that is the reason why the method that is easily washed away is method A, which is water washing. Follow? Yeah. I hope it makes sense. If it makes sense, then good. Anything else? Anything else? No? Are we going to continue? Let's continue. Otherwise, we will be rushing already. Yeah. Let's continue. Chapter 5. Chapter 5. Yeah. Chapter 5. Penetrant process. We have looked into the penetrant process before, right? But this is in a greater detail. We're going to go through it in a greater detail because we were talking about steps, but here it will contain more detailed descriptions of the parameters that are required during each steps of the penetrant testing process. Okay, let's consider. Alright, surface preparation is a pre-requirement before you apply penetrant on the component for inspection. So now consider you have already perform your surface preparation, contaminant remove, coating of paint you have removed completely, and then the part is dry. Then you will apply your penetrant. So here, penetrant application step. How do you apply penetrant? Few methods. Yes, few methods. At least 3 or 4. Let's consider one by one. One of first is immersion, or sometimes we call dipping. Right, the part is dipped into the penetrant in order to ensure 100% surface coverage with the penetrant. So immersion is one way. And then you also can use brush. You dip the brush in the penetrant and then you brush over it on the component surface that you want to inspect. Then you can use also pen. Of course, this will be expensive and most of the time will be used on the in situ environment, that means on site. When the area is small, alright, we use the pen. So it's neater in the sense that it do not drip. So pen. Then spray. Can you see the spray? Spraying from the can, from the container. The penetrant is the container, and then with the help of with the pressurized air, you spray on the surface of parts that you need to penetrant testing. Or you can spray it from aerosol can. Spray from aerosol can. So these are the possibility. And lastly, can you see this is called low pressure spray? Okay, and one of which also spray, but in this spray of penetrant on the surface, it is by the what we call electrostatic, with the help of electrostatic. So electrostatic will generate a negative charge. The other way around, sorry. The component will be grounded, and then from the gun, spray gun, the penetrant particle will be charged positively. So the droplet of the penetrant will be positively charged and attracted to the surface of the component that you want to apply the penetrant. So which is better? Of course, electrostatic is better because you can save quite a fair bit of penetrant because it will not be wasted, because if you just spray, it can end up somewhere. When you use the electrostatic spray, the particle, the spray of the penetrant will be attracted, even though they may move fairly a bit, but then attracted, right? Attracted. So it is not wasted. Yeah, it will stick to the component surface. Of course, you need extra cable, the electrical cable to cause the electrostatic different charges. You follow? Yeah. Not many facility has it because it requires additional component to charge the penetrant spray. Right? Otherwise, most of the shop will have this just a pressure, low pressure to spray out the penetrant. If you direct it on the surface, you will end up the penetrant on the surface, which is good. If you spray somewhere else, you just wasted. This one, even though the particles of the spray of penetrant is away a bit, but because the surface is being negatively charged in the track. Yeah? You can see the movement of that mist of penetrant being affected. If it works properly and effectively. Okay? How many types of method to apply penetrant on a component? How many? Immersion or dipping, brushing, pen, low pressure spray, or electrostatic spray. Basically, you can categorize it in 5 different methods. Okay? Alright, good. Then we move on. After you have applied the penetrant on the component surface, you need to allow a simulated time to pass or let the dwell times to elapse. This is the time taken for the penetrant to sit into any opening on the component parts. So dwell time is very important because it will be the time taken by the penetrant to enter any discontinuity opening. So if you look at here, when do you consider the dwell time? How do you measure the dwell time? So the dwell time starts from the time the penetrant is applied to the time it is washed off. Yeah? When you apply, and then to the time when you wash it off, wash the excessive penetrant from the surface, and that duration, that total time is considered as dwell time. So in that sense, you will come to know that it is including your drain time. Because the drain time means you drain, correct? There will be some time elapsed because the excessive penetrant will drip back into the tank. And that time is considered dwell time as well. You dip, drain, plus the time until you wash. Follow? That is called dwell time. So now, dwell time, is it fixed? Is it always 30 minutes or 20 minutes or 10 minutes? Even in your specification, it says dwell time is between 10 to 60 minutes, correct? 10 to 60 minutes. That is a big variation. A big variation in terms of choice of dwell time. What dictates the dwell time that you apply on your component? This depends on what? Type of defects sought, the temperature of the component under test, the surface finish of the component, and type of penetrant that you are using. So these are the factors deciding how long is your dwell time during your penetrant testing inspection. Okay? Follow? How long have you seen the requirement in your maintenance manual? 30 minutes? 30 minutes? Yeah. Some of the components require up to 55 minutes. Yeah, I have seen 55 minutes, and that is only once that I have seen. And that is on the high pressure turbine disc. High pressure turbine disc engine component, because the crack is so fine, and then they want you to have the dwell time as long as 55 minutes. So you can see here, if the type of defects that you are looking for is very fine, and due to that condition, your dwell time is generally much longer. You understand? Yeah, much longer. Okay, any problems so far regarding dwell time? No problem, huh? So you need to make sure sufficient dwell time. If not enough dwell time, chances crack that you're supposed to look for will not be appearing because penetrant does not have enough time to enter the discontinuity. Alright? So some of the dwell time is also depends on the customer requirement or your OEM maintenance manual requirement. Some is decided by operator, some is decided by your method level 3, PT method level 3. Some is determined by the company procedure. Company procedure will be your method level 3, but some is customer will be your so-called original equipment manufacturer, OEM. Yeah, they will decide how long is the dwell time. So be aware of all these conditions. So far, okay, we move on. Typical dwell time is about 10 minutes, maximum will be 60 minutes. That's why we have mentioned that is according to ACME 1417. Next, when we have allowed well time to elapse, the next step we have to handle is, it is known as penetrant removal. You remove the excess penetrant from the surface of the component, and you must do this under UVA light, with the background UVA light. Right? So it is you must ensure that the rinse station has appropriate illuminations during washing, because this will enable you to real-time tracking how much excess fluorescent penetrant you have already removed. This is to ensure no overwashing or no underwashing taken place. What is overwashing? Overwashing means you remove too much until to the point of penetrant in the discontinuity also can be washed away, right? So that become overwashing. How do you know whether you may have overwashed the component? When there is no background at all. No background, you have to be careful. Chances you have overwash. Alright? Underwash means you have not enough sufficient cleaning washing time. So then you will have too much of background. What is the disadvantage of too much of background? It is to do with contrast, right? If you have indication from discontinuity, background is too high, that will overmask or mask of the indication from the crack, and chances you will not detect it. Okay? Right. So that is slightly different in terms of penetrant removal method. Compare method A, B, and D. Compare with C. So look at method A, B, and C first. Method A, B, and C generally are method applied using the inspection line. Penetrant inspection line. Yeah? Yesterday when you perform the inspection using the penetrant testing inspection line, you will see you have a wash station, alright? A wash station, and then you will switch on your UVA light. That is your background UVA illumination. And then you use the water nozzle, either with a mixture of air and water or just water. Okay? So if it is just water, the maximum pressure should not be more than 40 psi. If it is air and water, it should not be more than 40 psi as well. But your air itself alone should not be more than 25 psi. You follow? Right. And then your temperature of the water. Remember, I mentioned to you, take notes of the water temperature. Right? If you are working in tropical country, not so much a problem, because it will fall within this range normally. Temperature of water should be within 10 to 38 degrees Celsius. Right? In the country where you experience winter, during the winter months, you will have temperature can go as low as minus or below 0 degree. If it is below 0 degree, what will happen? What will happen? The viscosity of your penetrant will be increases. Viscosity of penetrant increases. Alright? So that's where it's an issue if you work with low temperature in a low temperature environment when performing penetrant testing. Yeah? So temperature control is important. For washing, you must ensure the water temperature is between 10 to 38 degrees Celsius. Okay? Next, what type of water spray you should choose? Remember, when we washed our access penetrant yesterday during the practical, the nozzle, you need to make sure you adjust the nozzle head, correct? You adjust the nozzle head to get the fan, a cone shape of water spray, the cone shape, alright? Cone shape, not water jet. The water jet, the water will be of a high pressure nature. It will have the chances to wash off your penetrant from discontinuity. So it's a water droplet, coarse water droplet. One thing is the droplet must be coarse. What is coarse? It's not fine cut. Fine would be very small droplet. This one is coarse, reasonable size of droplet. Yeah, coarse. Then, after changing the head of your spray, get the coarse water droplet, you must control your water pressure. You know what is the water pressure? So remember? Yeah, it should not be more than 40 psi, but recommended is around 30. Remember, yesterday when we changed when we adjust the pressure, we adjust it around to 30 psi. So that is a good choice, 30 psi. Okay? And then next, we have to remind ourselves the distance of the nozzle to the distance of the surface of component that you want to wash away the excess penetrant must not be too close. You must maintain a distance of 12 inches whenever possible. Whenever possible. So now you can see pressure you need to control. Droplet of the water spray must be coarse, and the distance between your component and your nozzle head should not be too close. It should maintain not less than 12 inches whenever possible. Yeah? Okay. Next, I also have highlighted yesterday that you try to aim your water pressure, your water spray at an angle. Remember? At an angle, not at 90 degrees. So at an angle. When you are spraying at an angle, the pressure impacted on the surface will be much reduced, and you will indeed ensure the chances of the penetrant washed away from discontinuity is will be reduced. The chances of removing from the discontinuity will be reduced. Okay, watch out the distance and then watch out the angle. Follow? Right. So, why we are so concerned about the correct washing timing? Your wash away the excess penetrant, why the timing is very important? Because of this reason. The importance of correct wash time. And you must do it under the UVA light, because too long for wash time, you can cause overwash. This is how it will appear. Imagine the penetrant inside the discontinuity. One is deeper, another one is shallower. If you wash too long, you overwash. Under the UVA light, you will not see any indication at all. There may be no background, no fluorescence background on the surface of the component. And then, penetrant may have been completely removed from shadow effects. What about 2 shots of wash time? When you just wash insufficiently, very short time, then chances you are underwash. And underwash, the excessive surface penetrant still there. And if that is the case, under the UVA light, you will see too much of fluorescent background. And this will cause your crack indication not visible to you, because contrast is very low. Okay? So take note of that. So you can see here, can see here, there is a crack in this picture pointed by the white arrow. Under these circumstances, you can see the contrast is good. If it is somewhere here, you can't see much of the contrast. Very difficult to detect. That's why we need to ensure our wash time during penetrant removal is properly controlled. Yeah, ensure not over, not under. Okay? Understand? Good. Now we're going to consider method C, because method C is different from method A, method B, method C. Method D. A, B, and D, you use the inspection line. Method C is in situ. You will apply tissue, lint-free tissue to perform your excessive penetrant removal. How do we do that? So stage one, after the dwell time of penetrant, you will use a clean, dry, lint-free tissue, remove the excess penetrant. How? You wipe it and not to scrub it. How to wipe it? It means you wipe in one direction. What do you mean by scrubbing it? Scrubbing it is to and fro, scrubbing it. So we don't scrub it. We use the tissue, clean, dry, wiping it in one direction. And then if it is soil in one face, you fold the tissue and then wipe using the clean face of the tissue again in one direction. So that is important. Okay? Bear in mind, because this is tedious, so you have to concentrate and do it properly. If this stage you do not do it properly, it will become messy later on. Yeah? So you need to make sure you do it properly. Second, you will use a clean, lint-free tissue, moisten it with the solvent. When you moisten it means it is just slightly damp the tissue paper. Not to the point of soaking it with solvent. No, soaking with solvent is never allowed. You moisten it, you can feel the dampness, but you do not see the solvent dripping. You understand? So then with that, you will do the wiping again from one direction to another direction. If it's soil in one face, you fold it and then you do the wiping again using the clean side of the tissue. Okay? Remember, never spray solvent directly on the area you are processing. If you spray directly, you are virtually doing a cleaning, alright? Washing away the penetrant that has entered the discontinuity opening. So that is not allowed. Okay, after you have removed excess penetrant, the next is drying. Right? Drying. When we are talking about penetrant testing line, drying will be done using drying oven. So using drying oven. The drying oven, the temperature must be controlled. What is the temperature maximum that you can set for your drying oven? 73 or slightly lower? 71. That's correct. Yeah, correct. 71 is correct. 73 is exceeded. Remember, maximum allowable in our specification according to ASTM E1417, maximum oven temperature is 71 degrees Celsius. Okay? So it must be controlled, and normally it's air circulating, so that in the oven the temperature is distributed even. Yeah? Now, how long is the drying time? In the standard, they didn't give us the value. What is the maximum drying time? Because drying time obviously depended on a number of factors. What are the factors affecting the drying time? The part size, how big it is, how small it is. The part shape, is it just simple flat surface or with all those radius opening, and then with so-called combinations, fabrication parts. Alright, it all depends. And also depends on the material. Either it is a plastic, alright, either it's a metal, alright, that will affect the drying time. Lastly, it also depends on specification. Some specification may give you a fixed drying time. Depends what specification that you are using for your inspection. As we have mentioned earlier, you have rightly mentioned it. Under STM E1417, maximum oven temperature is 71 degrees Celsius. Remember that, yeah? And then, prior to putting into oven, what you can do is that you can use a clean air plus air to remove excess water prior putting into the oven. What is the maximum air pressure if you have this option? 25 psi. Yeah, you can use 25 psi air pressure to remove excessive water from the surface prior putting into the oven. How long in the oven depends on the time, depends on the specification, depends on the parts requirement, yeah, the shape, and then you let it dry properly, but never exceeded the time allowed, because chances of causing the penetrant in the discontinuity to become viscous, increases, and harden eventually. And you will not get irritation if it is viscosity is too high until no more volatile positive component inside, constituent inside, for it to reverse the capillary action when you apply it. Follow? Yeah. So oven is critical also, you must observe. This is how typical oven look like. You need to have temperature gauge. Alright, you also need to have setting, how much to set the temperature. Temperature gauge to measure the temperature in the oven. Setting the level of temperature in the oven is a temperature setting. Okay. So next is applying developer. Next is applying developer. How? Alright, there are basically three functions of developer. Developer has the purpose of reverse the capillary action to pull the penetrant out of the discontinuity. To pull, sometimes we call blotting, blot up. Or reverse capillary action, the penetrant now is pulled out from discontinuity out onto the developer layer. Next, developer has a function of enlarging indication. Normally, the developer has a layer. Yeah? Even though the layer is relatively thin, imagine this is a surface, right? With your so-called penetrant inside. And then you have a layer of developer, yeah, layer of developer, very thin, but when your penetrant is being blocked up, it will occupy a slightly larger surface, as well as there is element of thickness. So it actually has an effect of enlarged indication. Yeah? Enlarged indication. Cause the indication looks larger than it is actually is. It also makes the indication brighter. Why? Because when you use the UV light, that fluorescent dye will glow. So that's where we make indicator brighter under the background of white color. Under the background of white color, you tend to have the indication glow. So these are the functions of your developer. Understand? So developer is important. If in your maintenance manual require you to apply developer, you have to apply developer. There will be the case where some maintenance manual exempts you from applying developer. Yes, there will be occasion they allow you to do that. But often than not, applying developer is required. Any question? So far okay? Okay, good. Let's move on. Now, I want to draw the attention. Developer has the effects of enlarging the indication. So enlarged indication, you can detect it easily, but in terms of measurement of defect size, there are two ways of measuring indication. One is called indication size, another one is called defect size. Yeah, defect size. So if it is indication, then this would be my indication size. Can you pay attention here on the whiteboard here? This would be my indication size. You follow? It's an indication size. But if the written instruction requires you to measure the defect size, what would you do? You should not measure the indication size. Right? You should bleed out, use the solvent, remove your indication, let it bleed out. Alright? As it bleed out, you will have this defect indication clearly out. Clearly out there, and then you use your measuring device to measure this defect size. You follow? You follow? So there is a difference between indication sizing and defect sizing, and this is being explained clearly in your ESPN E1417. Depends on your written instruction what it asks you to measure. Is it indication size or is it defect size? Then you have to use different way of measuring. Understand? Okay? Then we move on. Can you see that? This case you can see it provides a contrast background. Which one is easier to see, with a white background and then the red penetrant indication? Or if you have a brown background? Of course, white background with red indication will be better contrast. So that's why the developer providing the white background in order for you to see the indication better because of the better contrast. Okay? Alright. But for your fluorescent penetrant, because you use UVA light, it emits that greenish yellow color. So as such, your developer does not really provide you the background. It just works with the reverse capillary action. to block out the penetrant from the discontinuity. Follow? Alright. So how do you apply developer? How do you apply your developer? There are a number of ways. Basically, first of all, we want to look at classification of developer first. You have dry developer, form A, water soluble, form B, water suspendable, form C, non-aqueous wet developer, form D, which we have covered earlier. Correct? More or less, we have revised earlier in the morning. We have seen that there are 4 classes of developer: form A, form B, form C, and form D. Okay, the most common one being form A, dry developer, and then form D, non-aqueous wet developer. Right? Then we move on to see how each of these developer can be applied. Dry developer can be applied by blowing the powder on with a bulb type of blower. You know, like the rubberized container, and then like a pepper dispenser with a hole. So you basically squeeze the bulb and then allow that dry powder to come up as a cloud like that and then settle on the component. So you need to build a skill where when you squeeze it, you pull out your bulb away. Squeeze, toss it a bit, squeeze, and then allow that dust, the cloud of dry developer to drop onto the surface that you need to apply the dry developer. You follow? So that is by what they call the bulk type of blower. Or you can immerse the component in a container of dry powder, dry developer. I mentioned earlier, yesterday, you can have a tank with dry developer. You just immerse it, shake it a bit, and then you have applied your dry developer. You follow? Yeah. Then, using a dust or Fox chamber where the particles are blown into an air suspension. This is what I mentioned yesterday. It is known as dust storm cabinet. In dust storm cabinet, you have the bottom there, you have the dry powder resting at the bottom side. And then you have this incoming air, pressurized air, to generate the cloud of developer, right? And then it will settle on the component that you place in that dust storm cabinet. Lastly, you can apply it by low pressure gun, spray gun, or low with electrostatic spray gun. Yeah, same like your penetrant application. Dry powder developer you can apply by spray gun, electrostatic, or just low pressure spray gun. You can. Depends on your facility in your workshop. Right? This is how the dust storm cabinet looks like. You place your parts inside and then you switch on the so-called pneumatic air, you kick the cloud of the dust, then it settles. That's how dust storm cabinet works. And then you have this electrostatic spray from the spray gun, and then again the dry developer powder will be charged positively, and your component will be charged earth become negative. So particle of your dry developer will be attracted onto the surface of your component that is earth that becomes negatively charged. Now, when do you use dry developer? So it is mostly applied on a rough surface. If you have a component testing for penetrant testing, form A dry developer will be used more commonly. Yeah? More commonly for rough surface. It is considered easiest to handle because when you apply and you remove, it is easier to do that with a dry powder. When you have rough surface, imagine you apply them and then you just use the air to blow it away. Alright? So easier to apply and easier to remove on the component with rough surfaces. They are considered non-corrosive, does not give off vapor, and leaves no residue or film to affect the next processing step. So if you have removed the excessive dry developer after inspection, you normally just wash it with water. Yeah? Spray water to let it wash away and dry, and that is sufficient. Right? We must understand there is a requirement because form A is considered of a lower sensitivity. When you are inspecting using type 2 visible dye, you should not apply dry developer in that penetrant testing because dry developer has lower sensitivity and type 2 also is considered lower. So both lower and lower you will have poor result. Yeah? Poor result. So that's why form A you will not use it with type 2 visible dye penetrant. Follow? Now for water soluble form B, water soluble powder, they are in crystal form and then you need to mix it with water. It is something like your sugar. Yeah, sugar, when you want to mix a hot drink, you add sugar crystal or sugar in a teaspoon and then you pour it into the water and you mix it. So the water soluble developer works the same way, right? You need to mix the crystal with the water. The mixture, after you have mixed them, you have to make sure you have the correct concentration. How do you check the concentration? By using this hygrometer. Picture hygrometer. You use the hygrometer to check the specific gravity, whether the concentration of your water soluble developer meet that requirement or not. Otherwise, your concentration, if it is out, you may not apply the developer properly and you may not get the result as designed. Follow? Right. The concentration will change over time due to evaporation losses. So need to be checked regularly and normally on a weekly basis. Okay, how do you apply the form B developer, water soluble developer? It is by immersion, by spraying or by flowing. So these are the most common. Most common one is immersion. So these are the three types of method of applying. Immersion being the most common way of applying form B developer. So we have covered form A. Form A is what? Dry developer. We have covered form B. Form B is water soluble. You have to mix it. When you have mixed it, can you see it or not? Diluted, you can't see. You just see liquid that is clear. You understand? Yeah. Can you see? This is how analogy. You have to dissolve it in water. Right? When you dry it, then you will form the crystal again. You follow? That's how the water soluble developer looks like. Just like seawater. Seawater, you can't see salt crystal inside. When you have diluted it, it is exactly like water. But if you were to dry it, then you will get the crystal salt again. So that's how water soluble developer works. What about water suspendable form C? Water suspendable. Water suspendable means the developer particles they are not dissolved into the water. They suspend. What do you mean by suspend? They're just floating, yeah, in the water. Yeah, they're just floating in the water. So now, because it's floating, if you do not have agitation, it will settle down. If it is settled down, then your concentrations of your developer will be not according to the requirement. So this water suspendable developer require constant agitation. You need to agitate so that the suspension is of the proper concentration. Alright? How do you make sure the concentration is correct? Again, we are using hygrometer. We are using the hygrometer to check the specific gravity of the water suspendable developer. So you have to check it regularly because water evaporates, and often it is checked on a weekly basis. And how to apply it? The same as the water soluble developer. You apply water suspendable developer by immersion, spraying, or flowing. And the most common being immersion. Okay? So we have covered how many already? 3. Right? Can you imagine this is how it works? The water suspendable is actually the particles suspend in the water. But when you dry it again, they will be crystal again. Right? Okay? Remember, you need to agitate constantly. Otherwise, the concentration will be not correct. Now, what are the disadvantages of water-based developer? What are the water-based developer that we have covered just now? 2 method, form B and form C. Water soluble and water suspendable. So what are the disadvantages? Right? They tend to leave behind a thin mark. Yeah, what they call leaving water rice mark when dry. Yeah, water marks. You have the crystal when it dry. You will have that water run marks together with the developer marks left behind when it is dry. That means it is not evenly distributed. Alright? And this happens if you have the surface of your component that is of high tension, right? High tension surface, and then the water, as it dry, you will have a streak of water mark together with the developer of different distribution. So that is not desirable, but this is the disadvantage if your surface tension is not managed properly. Next problem is that you may have developer trapped in blind hole. Certain hole, alright, doesn't have a true hole. It will settle there, and you have a very thick developer settle there when it is dry. Okay, or leave large deposit in threaded parts, especially like the nut screw. The developer tends to stay there because it doesn't flow well at the capture area. Okay. Lastly, we want to consider is non-aqueous wet developer. This is known as form D. Form D. So again, this is suspension. You have a powder of developer suspended in a volatile liquid solvent. Basically, suspension in a solvent. Just now, form C is developer particles suspended in water. This one is developer particle suspended in the solvent. You understand? Solvent. Right. We know that solvent can viscosity of penetrant, alright, when you apply the non-aqueous wet developer on the surface, when it reaches the penetrant, alright, that is enter in the discontinuity, that solvent will decrease the viscosity of the penetrant and increase the liquid bulk within the cavity. Yeah, because it dilutes a bit, because the viscosity volume reduce the viscosity and increase the volume of the penetrant in the cavity of the discontinuity. And then the volume enlarge, it will force the penetrant to come out to the surface. And compounded with that, in addition to that, the solvent evaporates fast. When it evaporates fast, it has a suction effect. It pulls the penetrant up. Right? So that's why physically you pull the penetrant into the developer coating for better visibility. Because of these two actions, non-aqueous faulty developer is considered as the most sensitive developer available for us to use. Yeah? The solvent cause the viscosity of the penetrant to reduce, increase the volume of the developer within that cavity of our discontinuity, forces the penetrant to the surface, and then the solvent evaporates, have that suction effect to pull the penetrant up to the surface. Okay, that's why it's the most sensitive developer type of developer. Okay? You can see here the volatile liquid evaporates rapidly on contact, eliminate the need for a separate delay drying operation in an oven or with fan. So in your method C, penetrant inspection, when you use non-aqueous wet developer form B, you do not need a drying operation. Yeah? Okay? Clear? Alright. How is it applied? Exclusively you use spraying. Exclusive means the only way that you apply non-aqueous wet developer is by spraying. Either if you have a container, you spray with a spray gun, or from the aerosol can. You just spray it from the aerosol can. Container must be thoroughly agitated immediately before use to ensure powder is properly suspended. That's why your aerosol can for your non-aqueous wet developer has a metal ball for you to eliminate the suspension properly. So when you have agitated for a short period of time, 2 minutes or so, you can see it is quite well used. Yeah, you can hear it. Right? Then always perform a light check spray away from the part to ensure the nozzle is clear and not spitted. Sometimes because of the solvent, alright, even though you mix, but the nozzle head here, the developer already dry, it blocked. If you just spray straight on the surface of the part, it is spitted out. Then you have a spot of one big droplet of developer on the surface, which is not desirable. That's why if you remember yesterday when we do the things of spraying, spray outside, just remember, try whether the spray is smooth widespread before we move on to the component surface. Follow? Okay. So apply sparingly. That means don't be too heavy. No, you are applying. So sparingly. A thin translucent coating is the objective, is what you try to achieve. So you will see the metallic shining of the part should still barely visible to you. You are not covering the whole surface with the whitish color. No. When you spray, you can see still the metallic shining part still visible to you. Right? That is the non-aqueous wet developer. Several coating are always preferable to one thick, heavy application. That's why several applications, several run of spraying, 2, 3, 4, depends on your product. Not just to achieve the thickness at one go. No. So 2 or 3, several light coats are always preferable. Okay? Clear? Alright, good. See how much more? Still got a little bit more. Think about 8 slides to continue. Continue. Yeah. Right? So you can see you must adopt a fairly large distance between 8 to 12 inches. Not too near. At the distance about 8 inches or 12 inches. Yeah, depends on your comfort spray. Not too near. Too near will not be good. Right? What about developing time? Development time. After applying your developer, you allow the developer to take action. How long should the time elapse before you proceed with your inspection? So what does it say here? Proper development time is very important in the interpretations and evaluations of indication. Development time is the time allowed between the application of developer and the viewing of indication. If insufficient time is allowed, indication may not have time to develop. Too much of time will cause indication to become blurred and distorted. So you should not allow your developer time to be too long. Too long it will grow, and then your indication size will be enlarged until it is no more distinct. Whether it is a fine line or it is a very broad line, you can't differentiate anymore. So that's why development time is important. What is the maximum development time for non-aqueous wet developer? 1 hour. Excellent. What is the minimum? 10 minutes. Very good. So that will be your guide. So depends on your inspection, depends on your written instruction requirement. It can be 10 minutes. It can be 1 hour for your non-aqueous wet developer or your Form D developer. What about aqueous? Aqueous water-based, either water soluble or water suspendable. The requirement is between 10 minutes to 2 hours. Okay, and then lastly, if you are using the dry powder developer, the timing is between 10 minutes to 4 hours. 10 minutes. Now, we are going to quickly look at why you need to use fluorescent or visible dye penetrant testing. Yeah? Why? We know aerospace, we don't use visible, but in terms of theory, when you come for penetrant testing, you must know the difference. There is a difference between type 1 and type 2 penetrant. Yeah? Which one to use? So, either type 1 or type 2 depends on what type of defects you are looking for. And then the components that you are inspecting, whether the size is very large or very small, in terms of geometry, it's very complex or it's just simple. Okay? And then whether you are doing it in a remote location without much amenity for you to depend on, or very remote that is very basic that you have to rely on, like an inspection kit, so on and so forth. It all depends. Right? Then what else? Surface condition. Is it a rough surface condition or very smooth component surface that you are inspecting? And what about the cost? Is it expensive? If I can achieve it with a cheaper penetrant system, then I will use the cheaper system, right? Rather than go for fluorescent when I can achieve the same result by using visible. So obviously, fluorescent penetrant type 1 is more expensive compared to visible type 2 penetrant. Okay? So these are all the considerations when we are considering which to use. Of course, under certain specification, we will specify you must follow fluorescent penetrant inspection. In what case? In aerospace case. In aerospace case, all penetrant testing must be performed using type 1. You don't have choice. But if you are outside the industry, you have the choices either to use type 1 or type 2. Right? Because it's not demanded on you by specification. Alright, what else? Is it rotating part or non-rotating part? Okay, and then it says here, highly stressed part or not highly stressed part. As I mentioned before, never perform. No, this is something new. Take note that it's something new. There is a requirement. If you perform level 2 penetrant inspection, you cannot immediately follow with type 1. This is a type of error, type 1. If you have inspected using type 2, you cannot immediately inspect type 1. Reason is that type 2, the residue penetrant material can kill the fluorescence of your type 1 penetrant. That's why if you, after immediately you perform type 2 inspection and then you just do a simple cleaning and you perform type 1, it's not allowed. You need to clean the component properly, thoroughly. Only then you can perform type 1 after you have performed type 2. You follow? Yeah. Reason is that two possibility, the type 2 dye continue to have residue in your discontinuity. It will prevent your type 1 penetrant to enter. That is one. Even though there are certain percentage of the type 1 penetrant enter into the discontinuity, the type 2 visible dye will kill certain percentage of your fluorescent ability to fluoresce. You follow? That is the reason why never perform type 2 penetrant followed by the other way around. Never perform type 1 penetrant followed by type 2 inspection. You follow? This is a mistype somewhere. Yeah? Basically, you should not do type 1 after you have done type 2. Follow? Yeah. You should not do type 1 inspection after you have done type 2. Right? That is the correct statement. Okay? Right. Move on. So we have penetrant testing, especially visible penetrant. All right. Under color contrast, the portable kits, what are available there? Okay, you have this cleaner. All right, can be class 1, class 2. If you are just doing the carbon steel component, class 2 can be used. Class 2 is what? Class 1 is what? Class 1 is class 1 is halogenated, remember? Class 2 is non-halogenated. This is cleaner, right? So depends on the material you are inspecting. Right? It can be class 1, class 2. Then it can be penetrant, it can be water washable or post-emulsified. Then developer is normally all the time, most of the time, will be non-aqueous. And then for carbon miscellaneous items for your portable kit will be the wipes, brush, marker pen, white light meters, and white light saws. Okay, these are the kits for your color contrast. Alright, you may also require a test piece, such as a tank panel, right, depends on the requirement. Alright, this is how it looks like for the portable kits for color contrast. Okay. What about fluorescent kits for portable site inspection? Cleaner, class 2, penetrant, either water washable, penetrant, or post-emulsifiable. Developer, most of the time they are not aqueous. You must have UniKL light, you must have white light, and the miscellaneous equipment, wipes, brush, marker pen, and then your UniKL and white light meter. Okay, so this is how it looks like. And then you have the UniKL light, and then UniKL radio meter. Okay, you may also require a test piece, a tank panel for your process as well. Have you seen the metal C requiring tank panel? No, yeah, yes, correct. Because under ASTM P1417, your portable metal C does not require tank panel. It's only applicable for, they call it in-use material. In-use material where you dip your component into your penetrant that require known defect standard, KDS. And that we use tank panel in place of KDS. You understand? Right. But there will be some documentation, especially for Rolls-Royce inspection. In situ, method C require tank panel. Yeah? Be aware of that. The Rolls-Royce engines, some of them in situ, using the portable kit method C, they require you to have tank panel to make sure your quality is under control before you proceed with your inspection. Follow? Yeah. Now, how does the penetrant be performed? It can be performed in what we call inline penetrant system. Means it is an inspection line, alright? Each has a separate station where different steps of process for penetrant testing is being performed in different stations. This is one straight line. What do you have? Pre-clean station, then you have a penetrant application station, you have a pre-wash station, you have emulsifier application station, you have a post-wash station, dry towel, then dust contaminate inspection booth. This is how many stations? Purely for ADT will be 1, 2, 3, 4, 5, 6, 7, 7 stations. What you have it here, you have only, this one is considered 1, 2, 3, 4, 5. Because you have only one wash station. Yeah? This one have 2 wash stations. Pre-wash, post-wash. If you perform your post-emulsifier penetrant testing this afternoon, you will use the same wash station. Pre-wash will be the same, post-wash will be the same. That's why we have 5. Follow? Alright. This is how it looks like on the workshop. Your line penetrant testing station, normally with a cover. Can you see the cover? Right? And then you have a raised up platform. I mean, when this cover is covered, this part will be lower down. Yeah, just apply by dipping, yeah? And you open again, you raise up. So that's how some of the penetration lines works. Depends on the system. Okay? Like ours, nothing, just everything manual. Yeah? some even automation, but this one is manual. Okay? If you don't have cover, if you don't have lid, then maybe contaminated. So the minimum you must have a cover. Yeah? You don't allow the dust particle drop into it. In tropical country, you can have cockroaches drop into it, or even lizard drop into it. Not so good, right? So you need to have cover. Right? Lipophilics. We have talked about this, but let's just quickly go for further explanation so that you can be more well-rounded. So understand this lipophilics emulsifier method B. It was introduced in the 1950s, so long time ago, and worked both with both chemical and mechanical action. How does it work? You see here, it says here, once the emulsifier has coated the surface of the object, mechanical actions start to remove some of the excess penetrant as a mixture drained from the parts. So your lipophilics application is by immersion or by flow. Only two ways. So when you flow, there is some mechanical washing away, right? But actually, you cannot use agitation. Can you see that? No agitation. No agitation. How does it work? Chemically, during the emulsification time, your emulsifier diffuses into the penetrant and resulting mixture that is easily removed when you spray with water. What do you mean by diffuses? If I release ammonia gas at one corner, if I release ammonia gas in one corner of the room, after a period of time, the ammonia gas will be diffusing into the whole room. And that is called diffusing. Diffuses. It will mix with the space of the air here and occupy the whole space of the room. Right? The intensity of course reduces, but it has the effects of filling up the whole room. You follow? That is diffuses or diffusing into the space. So when you apply the lipophilics emulsifier, the emulsifier diffuses into the layer of penetrate. You follow? Then, when it penetrates, it mix well with the penetrant. When you apply the water wash, it will easily wash away. Can you see that? That is, you must remember, it works in this manner. Diffuses into the penetrant. So, I also have highlighted, lipophilics is oil-based. You do not dilute them. Alright? So, that is the second important point. Application is by dipping or immersion or flowing. Two methods only. No agitation allowed because it is already worked aggressively by diffusing into the penetrant layer. Right? Do not agitate anymore. Neither can you apply it with spray because spray will give the force. When you have the force, your diffusing rate of your emulsifier into the penetrant layer will be different rate. Then you do not want to have a background that is not even. You understand? After you have washed that. So neither you can use brush because the brush have the hair that strap onto the penetrant layer. Right? So apply the developer at a different depth and different amount into the layer. So you are not supposed to spray, neither brush when you apply your lipophilics. It can only be applied by dipping and flowing. I emphasize this again and again because a lot of questions can come from here. If you understood the graphic, you get many marks for it from here. Understand? Yeah. Next. Not just level 1, same level 2. Because this lipophilics is a unique emulsifier. It behaves differently compared to what we used to. Yeah? Emulsification time is by experiment, but never exceed 3 minutes. For type 1, it is typical of for 3 minutes for type 1, for 30 seconds for type 2 penetrant. So, ranging between 1 minute to 3 minutes for lipophilic emulsification time. Remember that, yeah? So, remember? Emulsifier, lipophilics. You dilute it or not? Do you dilute it, add water or add solvent when you use it? You add water? No. Not diluted. Use as it is. Yeah, use as it is. They made because it's oil based. You don't dilute it. You buy in the drum, straight away you use it. No dilution. Important. You don't dilute it. So how will you apply it? It's applied by dipping or flowing. No agitation allowed. And what about how it works? What is the activity? It diffuses into the penetrant layer. Follow? Right. Good. If you grasp it, wonderful. Now, comparatively with the hydrophilic emulsifier, we have considered lipophilic emulsifier. Lipophilics mean oil-based, correct? Hydrophilics mean water-based. Water-based. It is water, just like your detergent. Remember, I told you, washing the dishes, detergent, if it is too concentrated, you add water to dilute it. So, hydrophilics is to add water for dilution. Can you see that? Always diluted. Okay. After dilutions, then you have to measure the concentration. Either 10%, 20% required depend on the OEM specification. So you can see here. Alright. Now, how does it work? Basically, it works as a detergent. You know what is detergent? Detergent is your soap is actually, how do you produce soap? It's actually from oil, From oil. Oil, you have some process, add certain things inside, and then that oil become this. One part of it, another part of it. Another part, this part will join with oil. You can join with oil. This part, the tail will join with water. Yeah? Follow? So, the detergent, they have one portion of that molecule, they can join with oil. One portion of that molecule can join with water. So now, if I have a layer of penetrant, this is my component, this is penetrant. What happened? If I apply my hydrophilic emulsifier, it will happen like that. Yeah? It will happen like that, and then it's just like a bite. A bite. Because it joined, it has a bonding. And then you require what? You require mechanical force to cause this to break away. Mechanical force to cause it to break away. So when you break it away, it will basically in this manner. You follow? You follow? It's just like a bite, taking the penetrant layer away. So that is where you can see here, hydrophilic emulsifier break up the penetrant into small quantity pieces from recombining or reattaching to the surface of the part, and then the mechanical actions of the water rings that you bring that away, to wash it away. So you have here, right, this part will be the green part. Yeah, this is the green part. And so you have small pieces, right? And then you combine this one water, to wash that away. You follow? Yeah. That's how it is. Right? Okay. Now, because of that, can you see? You need agitation. Imagine no water, no agitation, and you stay there. It will not work. So you have to wash it away, and then before washing away, you have to agitate it. That means when you agitate it, you will also move it away, and then replenish the new one coming. Agitate the new coming. So layer by layer, you remove, and then when you wash it. You follow? So that's where the hydrophilic emulsifier reaction is less aggressive, better control. You understand? That's why lipophilics is no more in use, very less, but hydrophilics is more in the use in aerospace because you can control better. Follow? Yeah, you can control better. Right? Then application is by dipping, flowing, spraying. For hydrophilic, spraying is allowed. But take note, if it is a spray in your ASTM E1417, what is the maximum dilution allowed? You know, normal dipping depends on the OEM of your emulsifier. It can be 10% or 20%. But when you are spraying or flowing, your hydrophilics concentration maximum is only 5%. 5%, because you already have that spray mechanical action. Yeah? Limit it to 5. You understand? So I hope that makes sense. Yeah? That's why it is controlled how much the concentration must be diluted. Agitation is needed. Agitation is needed because of this replenishing. And then lastly, don't apply by brush. Same, the brush will have that hair, yeah, scrap it in that manner. It will be uneven emulsification effect. Yeah? So a lot of questions can come up from here. Yeah, a lot of questions can come up from here. At least 2 or 3 questions can come up from here. Right? Take notes. Alright. What else? This is how immersion looks like. You just immerse. Maximum 2 minutes. Right? Never brush. If it is a spray, you can, hydrophilics can spray, but lipophilic never spray. Right? You can flow using the flow. It's not mentioned here. Okay? Quite a long chapter. I think we better stop. Alright? I think it's good time for us to stop for our lunch break. Yeah? Lunch break, when we come back, I think we will cover can we cover one more chapter? Okay. Can we come back and then cover one more chapter? Chapter 6. Yeah, chapter 6. We are a bit behind from what I intend to do.
Never mind, I think we can still catch up because chapter 7 and chapter 8 is, especially chapter 7 is short. I may try to cover chapter 6 and chapter 7 after lunch. Alright? So, welcome back. Hope that you had a good lunch, short rest. Let us continue from where we have left behind. 2 more chapters before we move on to our practical for today. Yeah, so we're going to cover chapter 6 and 7 and try to finish these 2 chapters before we go for practical. Okay, what is chapter 6? Chapter 6 is regarding ultraviolet light and fluorescence. Okay, because we are using type 1 penetrant. So type 1 penetrant has the fluorescent dye. We need to look into the light as well as the dye of penetrant. The light we use are used for inspection, and the material, the dye that fluoresces when it being energized by the ultraviolet light. Okay, for type 1 penetrant testing, you need special lighting. What is that special lighting? It is known as ultraviolet light. But not just any ultraviolet light, but it is actually limited to a region within the ultraviolet light. Let's see. This is a picture of the electromagnetic spectrum. Okay, it shows us the spectrum with wavelength that is smaller on the left hand side, the higher wavelength of electromagnetic wave, longer one is on the right hand side. Okay, so on the right hand side you have those waves that is visible here, and then you have infrared on the further right hand side. Okay, if you go further, you will have radio wave, and so on and so forth. Well, what we are interested is the electromagnetic wave that is on the left hand side from the visible light. That region fall after on the left hand side of the visible light is called UV light. Okay? And if you go further left, you will have the region what we call X-ray, gamma ray, so on and so forth. And their wavelength even shorter. Okay? Now in this region of ultraviolet light, you can see it is divided into 3 regions: UVA, UVB, UVC. Okay? Now, in terms of wavelength, UVA has a relatively longer wavelength compared to UVB and UVC. Okay? And because of shorter wavelength, it basically is more hazardous because it can change our human cell or damage our human cell. That's why shorter the wavelength, it is more dangerous. In our penetrant testing, we exclusively use UVA. The effects of UVA can cause aging. If you expose too much of UVA or UV light, it can cause aging. But if you expose more on the UVB, can cause burn to your skin. That's why sunburn. You expose yourself too long in the beach. On the beach. Okay, you will have this sunburn. What about C? C, if you expose too long, can cause cancer. If you remember during the COVID-19 times, alright, a lot of airlines cannot fly. Then subsequently, as the air travel back to normal, at the earlier stage, the airline used the UVA to kill to what they call to clean the cabin, those people who are handling the UV light is wearing the safety overall. Then they will clean the cabin using the equipment to shine on the seat, on the cabin, and so on and so forth. And that they're actually using UVC. Because UVC can kill organisms. Yeah, kill organisms, like virus, bacteria, so also. So you can see the operator must wear the PPE, right? Okay. Now, just to be more accurate, UVA light is actually in the region of wavelength between 315 to 400 nanometer, whereas UVB is between 280 to 315 nanometer. UVC is between 100 to 280 nanometer. So you can see UVC is the shortest wavelength, and then the longer wavelength is UVA, and in the between is actually UVB, and each of them is used differently. Can you see that? UVA is mainly being used for energy inspection lamp. UVB used in the examinations of material and in sun lamp. What is sun lamp? Yeah, you know, like the baby when they are born, they have the jaundice. The skin appear yellowish, the eyeball appear yellowish. So normally doctor will prescribe the baby be covered with the eyes and shine under the UV light. And this is the band that they use. Right? Then lastly is UVC. Can you see that? It is used in Germany's or sterilizing gland. I mean to kill the germ. Yeah, to kill the organism. So these are the usage. Now, how does it work? When we are talking about UVA, alright? When you have UVA light shining on your fluorescent material, your fluorescent dye, you know atom consists of proton, neutron at the center in the nucleus, and you have the orbiting electrons around it. And outer electrons orbiting orbits, that is where the energy of the electron is the highest. Now, if you shine your UV light on the fluorescent dye material, the energy given to this is supposed to be on a slightly lower, okay? Slightly lower electron orbit, it will be energized and move to the higher orbit. Yeah? Imagine it is somewhere this one. You receive the UV light, it will go higher. The electron will move higher to the outermost orbit. And then, after it reaches there, it will drop back again. When it drops back, it will give up energy. Yeah? It absorbs energy from the UV light, and then it drops off to the lower level. Okay? And then it will give up light that is in visible range, that is greenish yellow color. You follow? That's how the fluorescent materials work. So you can see here, right? The collision with the incoming energy or absorption of energy by electron. Okay, you excite electron, this causes the electron to jump to a higher energy level. Let's say this one will jump to the higher energy level, to this level. And then the electrons fall back to the original orbiting level, and extra energy released in the form of light. And that is in the color of greenish yellow. Yeah, because the fluorescent molecule, put it the other way, the fluorescent atom is actually fixed. Their level of electron level is also fixed. That's why it's always greenish yellow. You follow? Yeah, good. So when it goes down, it will release the energy. Just now it was up, now go down, it will be releasing energy. Okay? Yeah. This is not correct, it's a wrong sequence. Yeah, wrong sequence. It's supposed to be from here, it drop down in here, and then it go up because of the absorption of UV light energy. Yeah? Hold on. Agree? Agree, yeah? Somehow it's reversed in this picture. Now this is how it looks like. Right? Absorb UVA light. What is the range? 315 to 400 nanometer. It's a lower wavelength. Then after the electron absorb the energy, it will release. It will release a light that is in the visible range. The visible range of yellow, greenish color. The wavelength is between 510 to 550 nanometer. If you can remember the paper, because in level 2, some of the questions will ask. Yeah? From in the range of 350 to 400, it absorbs that wavelength energy from UVA, and then it will release, okay, at a higher wavelength of 510 to 550 nanometer. Okay? Right. So you see, UV light can be used in many things. You can view different organism or insect and give different color, right? And they glow with this fluorescent insect. Certain fluorescence in their shell, they produce different color to shine UV light on it. Likewise, in some minerals, the same. It absorb and then it give out light with a different color. Okay? The fish also, right? Very colorful, especially aquarium, can be costly as well. Yeah? Very colorful. Flower, some plant, you shine the UV light, it will give out different wavelength light, different color. Okay? So in our so-called work, how do we generate UV light? How do we generate UV light? Suns will give out white light together with UV. That's why if we go out with this sunburn, too long we can get cancer, alright? But in our society, do you know that this fluorescent lamp itself produces certain amount of UV light? That's why if you use the radiometer, you measure there is a certain amount. Okay? But the amount is much lower compared to the white light. Okay? Now, how to produce UV light? You can see here fluorescent tube. We use fluorescent tube to provide the background in our wash station. Background UVA light to wash our parts. So that is meant for background illumination. So a fluorescent lamp or fluorescent tube is a low pressure mercury vapor. Inside you have mercury vapor. Right? A gas discharge lamp that uses fluorescence to produce visible light. Okay? Now, if you work in your shop, you can see also what we call fluorescent tube. It's covered with one coating. What color is the tube? Very black, dark in color. Normally black with ultraviolet color, very black color. So that is actually a filter. Yeah? The same fluorescent tube covered with filter, when it comes out, it's actually UV light, the white light is being blocked. You understand? The white light being blocked. So, how does it work? In the tube, it's vacuum, it's filled up with mercury vapor. And as the voltage pass through, the electron pass through, it will excite your mercury vapor and producing visible light together with the UV light as well. Fluorescent tube, the intensity is low, must not be used for inspection because the intensity is not high enough and it is also not focused. Okay? Now, the different type of UV light, we have this high pressure mercury vapor bulb. So this is slowly being phased out. Right? This is how it looks like. It's high pressure inside. And then because it is vacuum, you need to use a high voltage to cause the mercury to give up the high intensity of the UV light as well as white light and some other such as heat, so on and so forth. So you can see that it produces a high intensity light which can be focused and set as a flat line. So it focuses from the front, it shines through the front. The output density of this varies from lamp to lamp, even though same manufacturer, same manufacturing processes, but different bulb behave differently. Okay. Then they require a warm up. That's why mercury vapor lamp will require warm up. Normally either 10 minutes or 15 minutes, sometimes 20 minutes. You need warm up. Reason warm up is that mercury, it will be in the liquid form. You need to warm up to make sure enough time given for it to evaporate to become vapor. Yeah, that's why warm up is important. Yeah, warm up is important. If you switch on straight away to do inspection, chances of intensity of a UVA will be very low. So when you warm up, then it will reach the maximum. Yeah, maximum. You must have a filter in front, normally filter in front or coated over the bulb. Used to have coated above the bulb, not approved after that because the filter gives way. Yeah, then once filter damaged, then you have white light emitted out. So they don't allow that, and they have just a filter outside now. So that filtering system, the filter sometimes is known as COPS-41 or wood filter. Right? They are specially formulated chemical substance that has been invented and applied on the glass so that they will block white light as well as UVB and UVC. Okay? By the way, this wood is not wood, it's just a person's surname. A person's surname Wood, just like Tiger Wood. Tiger Wood is a surname of the person who have invented the filter. Follow, Then, when you operate this type of light, it is generating a tremendous amount of heat. So it can be very hot. Alright? And normally at the back of this lamp, there is a fan, cooling fan. If you are not careful, if you touch the older type without cooling fan, you can burn your skin, your hand, because the amount of heat generated associated with the UVA is very high. Now generally, alright, the lamp being used for UVA is rated as 100 watts. Yeah, 100 watts. 100 watts will be sufficient to produce the intensity of UVA light that we require for our NDT penetrant testing. Okay? Right. What about gas discharge lamp? This gas discharge lamp, they use electronics and and they use, you know, the solid state, yes, the LED. LED, they don't have vacuum, they don't need to warm up. So it says virtually no warm up required. You switch on, right? Normally, switch on, you will have the highest intensity. This is the opposite. When you switch on, you have the highest intensity, but instead of warm up, you will allow it to. Okay, sorry, this is slightly different. Sorry, this is slightly different. That one is under LED. This one, gas discharge lamp. Okay, no warm up required. It produces low heat output. It gives you very high intensity. It can be flat, it can be focused. Flat in the sense that some of it you can use it as a background. Okay? And then broad spectrum of emission. You have a broad spectrum, but you need to have a filter in order to provide you the required UVA. Okay? And this is LED. This is what I tried to explain earlier on. LED is slightly different. You have the LED unit or elements. When you pass the potential difference, the voltage, it produces the light that is very bright. And you need the filter to allow only UVA to come out, the rest will block it. Okay? Can you see what is the wavelength here? What is the wavelength there? 365 nanometer. 365 is actually in the middle. UVA range is 315 to 400. 365 is in the middle. i.e., it means that this light with the LED has been designed specifically to give you the peak intensity of your UV concentrated at 365. You follow? And 365 is the required wavelength to effectively cause your fluorescent dye to fluoresce. If you have some other wavelength, such as 385, such as 395, it will not be the peak. The fluorescent given up by your type 1 penetrant will not be the optimum as required. You follow? So 365 is the best. So what about here? Right? UVA is used in fluorescent penetrant testing. What you need is 365 peak nanometer of your UVA. It causes the additive in the detecting media to fluoresce, adding interpretations of the indication. UVA light source used in fluorescent penetrant inspection uses a mercury vapor capsule. Okay, this type of lamp emits visible light, UVB, UVC, in addition of UVA. It means how many types of light available? Visible light, UVB, UVC, and UVA. So visible, UVB, UVC need to be filtered. Yeah, example of the filter is Wood's filter COX 41, which must be in good condition. Okay? Otherwise, if there is any crack or broken filter, white light of higher intensity will be emitted. If you are inspecting using UVA with high white light intensity, you may not detect very fine crack. Okay? So that's why during your inspection, your background white light should not be more than 20 lux or 2 foot candle of the background white light. Okay? general requirement for inspection. This is a general, and the value is provided by ASTM P1417. Remember your workbook there yesterday when we went through the same. Yeah. So what is the minimum requirement for your UVA intensity? 1000 microwatts per per centimeter square, right? And then for your ambient white light, when you perform inspection, should not be more than 20 lux. Next, your white light intensity, if you were to do interpretation or evaluation, right, you need to make sure you have the white light intensity of not less than 1076 lux. Okay, next, every other inspection need to be schedule free as possible. You should not have schedule. If you are having a UVA light hanging and you have shadow of your head as an example, it's not allowed because your intensity on the surface of inspection will be affected. Remember, avoid glare, right? If possible, you shine your UV light in one side here, come up here at an angle. If it is at an angle, not to your eyes, it will glare. Understand? Next, avoid UVA. Allow UVA to warm up approximately 15 minutes or 20 minutes, depends on your specification. Can you see here? This is what I try to explain. For LED lamp, you allow stabilization time. It's not called warm up because LED behave differently compared to mercury vapor bulb. Mercury vapor bulb, you have to allow the times for it to warm up so that all the mercury vapor evaporate, right? Become distributed in the tube. Whereas LED lamp, you switch on, you have the highest. Just now the discharge that the same. But in this case, after a short period of time, normally less than 5 minutes, in the region of 3 minutes, the highest one will dip down and then stabilize. LED has that property. It goes, switch on highest, it needs some time to stabilize it. That's why LED, you need stabilization time. Normally around 3 minutes. Okay? Well, this one, mercury vapor lamp, you need to warm up the mercury vapor. That's why you need 15 minutes. Yeah? It will slowly bring up the intensity up. Then stabilize. That's where you use the lamp when it is fully stabilized. Follow? Right. Now, dark adaptation, when you are doing inspection, you have to make sure, right, you have allowed at least 1 minute to adjust your vision in the dark. Then, while performing inspection, you make sure photosensitive spectacles or sunglasses are not worn during your inspection time. Follow? Clear? Good. Then we move on to light that is with filter and without filter. So what happens is that the filter in the LED, can you see that? With filter, it is cooler. There is no glare. You can see without masking of that bright light to your eyes. You can see clearer and able to detect smaller defects. Well, here, can you see the glaring? Yeah, the glare. When it's glare too bright, so the contrast is much reduced, and chances to detect the fine small crack will be less. How do you improve that? Besides you use the filter for your LED light, you can also use these glasses. Yeah? Have you seen this before? No? If you buy LED lamp, sometimes they come together, especially product from China. They give you together with a pair of glasses. You're supposed to be able to intensify the block of the lamp and then be able to give you the better contrast to look at the smaller possible effects. Okay? Safety precaution. When you use UV lamp for inspection, make sure the lamp filter is intact. And normally, due to safety reasons, if you observe your filter cracked or missing, you should not use the UVA light. The requirement is to replace it immediately because of the possible hazard risk that is involved. Follow? Then avoid looking directly into the UVA light source and from its reflection. Where you improve spectacle, right? Some spectacle are specially designed to protect your eyesight, especially from the UV reflected light. When you look at it directly, your vision will be blurred for a short period of time because your eyes also fluoresce. Do you know that? Your eyes can be fluoresced due to your UV light shine on your eyes. Yeah? Then cover your exposed skin with sleeve, dust coat, that will cover. Do not wear photochromatic lenses. Okay? And that is because of more for your inspection. If it is photochromatic lenses is become darker, chances you will miss the effect. Allow a dark adaptation period which we have covered. Subdue ambient light is required, we have covered. Odor, style, lamp generate considerable heat, so we have to be careful so that we do not touch, otherwise we get burned. And then take regular breaks. After you have inspected for some time, because your eyes indirectly also exposed to UVA, it will get tired easily. So take regular break. Recommended maybe every 2 hours you have 15 minutes break, something like that. Okay? Can you see this? Which one is more detectable? On the left hand side or right hand side? On the right hand side. It's because the contrast. This is very bright. When you have too bright background and this indication behind the background, the contrast is very low. If you wear this type of photochromatic lenses or you did not wash it properly, this will be all contributed to the poor contrast. Follow? Now we need to understand why dark adaptations of your eyes is important. Okay, let us consider this. Okay, if a small candle is lit in the light room, its flame may not be noticeable. In a very bright room, you put a candle at the corner, very difficult to detect. Yeah, right? That is observation. So if the room gets darker, the flame seems to get brighter. It is not because physically it gets brighter, but because our eyes slowly get adapted to the dark environment, and there is a difference of intensity of light. We can see it more sensitively. You understand? Then if you enter the dark room containing a candle, you would instantly notice the candle. If you are from dark environment, you go to the dark environment, if there's a candlestick there, lighted up, you will straight away notice there is a candle there. Okay, that's why dark adaptation is important. So this is because to see small light source in dark room is also worth noting that the dark area is harder to discern color and texture. In a dark environment, color doesn't have any, you can't really differentiate the color, right? As well as texture, you cannot say it's rough or smooth. So under darkness, we can only easily detect the light, but not the texture. Neither do we can discern or make a difference regarding the color. Okay? And this is just our human eyes, how we behave. Our human eyes, how it behaves. So you can see here, right? This is bright light. This is completely dark. Alright, in darkness. What happens is that our eyes have different cells. Yeah? The cells work differently. There are two types. One is called photopic vision, another one called stopic vision. Photopic vision. So during the bright environment, which one works better? Photopic vision. Can you see that? The light, it works maximum during bright light. So your eyes cell that function best under bright light is photopic vision. As you enter to a dark room, slowly another eye cell will function better. In a total darkness, which one works best? Scotopic vision. That's why you need to allow some time for this scotopic vision to take over. Yeah? From very bright environment, you go to the darkened environment, you need to allow your eye cell to switch, allowing the scotopic vision to function well. That is why dark adaptation is very important. Follow? Right. Now, it says here, it generally takes about 20 minutes for human eyes to adapt to the darkness. So when we consider this and carry out inspection in a dark room, we must allow time for our eyes to adapt to our surrounding. Most specifications mandate at least 1 minute for eyes adaptation before inspection before we start inspection. We need to allow at least 1 minute for our eyes to adapt to the darkness. And this is more so clearly stated in ASTM E1417. In paragraph 6.5.2 of our E1417 specification, it says here, dark adaptation. Personnel must wait at least 1 minute after entering a darker area for their eyes to adjust to the low-level lighting before performing fluorescent penetrant testing. So this is, unfortunately, it is from 1444. Yeah? We extracted wrongly from that. Okay? And you see a lot of possibility to make mistake because similarity. But take notes, the requirement is the same now. Used to be different. One place they will say 1 minute, another place they will say 3 minutes. But even under the same ASTM, but now both has already aligned, both require 1 minute. Right? So it's the same, requirement is the same. Whether paragraph is the same or not, we need to check. But requirements still the same. Understand? Any question? Any question? Alright? No? So far okay? Good? Yes? Good or no good? Okay, okay. Okay means you can follow, yeah? I will take it anyway. Alright. So, as I mentioned, we will try to complete chapter 7. Yeah? Chapter 7 is shorter. So, bear with me. We finish chapter 7, then we will go to our practical. Yeah? Chapter 7 is penetrant indication. It will help us. Yeah? If we cover, then later when we do practical, this becomes clearer. So, basically, repeating again, right? What are the type of indication you can encounter during penetrant testing? 3 types. False indication, or sometimes known as spurious indication, or true indication, and then this can be breaking into 2, relevant or non-relevant. Yeah? So these are how indication can be divided into. Can you see here? What is this? This one looks like your thumbprint, correct? A thumbprint, yeah? Your fingerprint, somehow imprinted on the surface. So this type of indication would be false indication. Very, very good. And then look like here, very clear, very smooth. Is it relevant or not relevant? Very difficult. Sometimes you may have to refer to the document, drawing. Is it part of design feature or not? If it is a part of design features, then it becomes non-relevant. Even though it's a true indication, but not relevant because it's part of the design. Yeah? But if it is not part of the design, it becomes relevant. You understand? So you have to refer. There will be time when you are not sure. Then you have to refer to the drawing. Is that part of the design features or not? Clear? Okay, good. Then we can see here these are the obvious crack. So obvious relevant indication. Understand? Okay. So what are the false indications? Where does it come from? False indication come from operator hands. Just like the one we saw just now, contaminations of developer. So if your developer already contaminated, you apply on the parts, that indication is on the parts now. You follow? Then penetrant on inspection table. So when you have not good housekeeping practices, your inspection table with a lot of stain. When you bring your component, turn around, chances you have this false indication because that penetrant material transfer onto your parts because of your table of inspection that is contaminated. Follow? And then penetrant transfer to clean specimen from other indication. So sometimes, somehow you may even use certain, let's say, measuring instrument, right? That has been stained. You measure it on that part, you transfer from a clean, the dirty to the clean surface. So that can happen. What about washing? Yeah. False indication may take place if you have poor washing practice. Like your glove has been stained with penetrant, touch, right? And then touch the component, and you have washed that part, you touch the component, the glove is still full of penetrant. But when you are rushing that part, you just leave it as it is. So poor washing practice, right? Fingers, and this is poor washing, and you can see, right? Stain everywhere. This worker must be very hardworking. Splash everywhere. The glove carry forward and then transfer to a new clean parts. Yeah. Now, what about non-relevant indication? discontinuity that in most cases are there by design. Remember, it is there because of design. And they are still called true indication because it has bleed out again. Right? Whenever you have a bleed out, you wipe it bleed out, it's true indication. But is it relevant or non-relevant? Non-relevant because if you have a bushing, there is a tight fit, there is actually discontinuity, right? The penetrant still can enter. When you rub it by bleed out technique, penetrant still can slip out. It's true indication, but non-relevant because it's something that you are not looking for. It is part of the design. So you check, confirm, part of the design, you will declare it as non-relevant. You follow? Okay? You can see here, non-relevant indication can also be real surface discontinuity that are not there by design, but do not exceed the customer acceptance criteria. So we have mentioned if it is relevant, then we have to check acceptance criteria. Correct? If it is below the rejection criteria, then it becomes not relevant to you. Yeah, you don't have to. Okay, I hope it's clear. Then we move on. Relevant indication. You can see here, these are indication from unintentional discontinuity or imperfection and must be evaluated against the specification or standard. So you can see here crack indication. You can see this also crack indication. You can see here, alright, crack indication. And this one, as I mentioned, it can be relevant, it can be not relevant. You have to refer back to the drawing. Yeah? Because it is too smooth. You understand? If you have a symmetrical shape, too smooth, chances is part of the design. But check to make your final decision. Okay? Right. So wipe off technique. Remember yesterday when we performed our method A, if there is an indication, what do? You use the wipe off to make sure it still got the lid off coming up. If without lid off, after you reapply the non-aqueous wet developer, then you confirm it is not, right? If it is appear again, then it's confirmed it is valid indication. Okay? How do you do that? Wipe indication using a swab moisten with a solvent. Apply developer, wait 3 minutes for non-aqueous wet developer. If it is dry developer, you have to wait 10 minutes. Inspect under UV light. If it is reappearing, you have to confirm that indication is valid. Follow? Right. Summary. True indication can be defects or can be non-relevant if it is part of the design. False indications are caused by poor practice. A crack that falls below the reportable size is considered as non-relevant. A crack or defects exceed the reported size is considered relevant. Right? Discontinuity can be a feature or defects. It can be a design. Features mean part of the design or can be a defects. A wipe-off check may be permitted to confirm an indication type. How many times? STM E1417 allows you to wipe off how many times? 2 times. 2 times, yeah? 2 times. Then cleanliness is essential to avoid false indication. Okay? That is completed our penetrant indication. So you yourself have experienced it during yesterday practical. At least you have located crack indication already for the part that you have performed using method A. So hopefully with this you will improve further. Alright, we will stop here for our theory. Let us now go to our practical. Practical, today you will do Method C, just method C. Yeah? Method C and method C is this one, method D is that one. For you, okay, method C is this one, method D is that one. So what we can do is that we will apply method D first, and then as we wait for the dwell time, we'll process the method C as well. Follow? Alright. To do that, I want to show you the temp panel again. Yesterday, when you use the temp panel, you use a dedicated temp panel for method A. So if you were to do another process is called method B, you have to have a different temp panel. You follow? Okay, let's do so. Get your apron. Okay, get your apron. I might just work on it. You can use this one, so then you just dispose it. Alright. Okay, your gloves. Today we are going to make use of this two tanks. So the lid I have to open up. Okay, this is emulsifier. Alright. And then this one is the hydrophilic penetrant. Okay, PE hydrophilic penetrant. It's the same, alright. It's a magnet flux ZL37, sensitivity 4. Okay. So let's apply the penetrant first, and then we will measure the concentrations of our emulsifier while we are waiting for the dwell time. Okay? Yeah, good idea to use the box so that you control the flow. Right, just dip it, right? Okay. So I will demonstrate in one component also, yeah? Just to show you should know how to do. Never mind, I will also do one. Okay. Put it here. And for you, okay, your part, you will put it there. Alright. I will also at the same time I need to make sure it is dry. Yeah? Otherwise, then I will dip your part first, then I will dip this one. Okay? You dip yours, yeah? You want to wear the apron first? You can wear. Okay. This one, better. Okay. Use the container. Just dip it. Dip it, yes. Okay. That's right. Just bring it up and then use the container. As usual, after you have dipped it, you have to make sure it is covered. Make sure all fully covered. Alright? Okay. Because we fully dip, so chances will not be there's something there, but it's okay because that is where it is. Yeah? Okay, good. 100% covered. That's good. Make sure your glove is clean. You can actually go and wash it in water. Yeah, wash it in water because we need to handle it later on with the emulsifier. Okay, wash it in water. Yeah, or you dry it with your tissue. Next, I will also put my temp panel. Okay. Minutes if you have the stopwatch, yeah, 20 minutes. When you clock 20 minutes, let us move on to our method C. Thank you so much. Method C. We have done with this one. We can close it up. Okay. Method C. Let us do method C here. Yeah, method C here. Take your sample. Okay, you need plenty of tissue. Maybe you just bring your tissue paper somewhere. Okay. I will also temporarily close this one because I only use it later. Alright, just this one will do. Okay. So for this method C, what you can do is you use the cover. Okay, you use this cover. Alright. You spray certain amount of this. This one is ZL-278. What is the type? Type 1, method C, sensitivity level 3. If you check on the website, the product, this is their category. Yeah? Spray inside the booth. Yeah, then use the brush to brush only the area required. For this is a welding, the weldment area. Can you see the color, this colorization? This is a HAZ, heat affected zone. So you cover here and cover here. You follow this area. So you do that for you. This is the area that you need to cover. Repair area. Can you see the weldment repair? The normal is like this, but they found crack. Then they repair it with localized welding repair. So you just apply here. 1, 2, 3, 4, 5. Just here. Then you process accordingly. Okay? Alright. Do that by spraying first. Then use the same container, you can apply. At the back, leave it, no need. Yeah? We just tackle the front surface. But the actual requirement is both sides. You follow? Yeah. For this exercise, you just do the top surface. Okay? Alright. You just spray it here so that it is controlled. Just spray and then get settled down. Right? Make sure it's dry. Yes. Three more. Okay, enough? Is it enough? Not enough. Slightly more. So, because the 3 of us want to use it. Okay. Right? Okay, should be enough. Let's start. Yeah. Use the brush. And then you want to just put it with the tissue. Likewise for you. Okay. All right. Okay. Yeah, she also apply one side only. You also one side. Yeah, and report whatever you find on that one side. Okay, after you have applied, remember, just double check with the UVA light whether the area of interest is all covered with penetrant. Yeah, use that. Maybe you just want to take your, if it is clean enough, you can. Good. All cover? Okay, good. Okay. All right, covered. Okay, let me do mine also. We will process and we see. Yeah. For me, I will just cover this one also. I just cover because mine is small. Okay. All right, done. So these are, we just put it aside. And what is your timing for the first one? How long? So another 15 minutes or another 10 minutes? Another how long? Another 10 minutes. Okay, another 10 minutes. In the meantime, correct? Okay. In the meantime, you want to fill up your report, whatever informations regarding the chemical batch number. Yeah, your exam is the same. You need to make sure you get all the chemical name as well as batch number and the expiry date. Okay? Well, you have that extra 10 minutes, you can do that. So, yes, the next page of your report form, you can do your method D, then lastly method C. Yeah? Alright? Fill it up, and I want to show you how to measure the refractometer, how to measure the concentration of your hydrophilics using refractometer. You fill it up first, whatever you can, and I will quickly show you how to do this refractometer. Yeah? Component name. Okay. Component name for you is the fan blade, but let me just open for you. Yours is this one. It's actually HPC. HPC. Yeah, stainless steel HPC. For safe, yours is also not HPC, HPT blade. HPT blade titanium. Yours is titanium. Yeah? Material titanium. Right? Good? Alright. Anything else? Okay. Your procedure. D, and then C, and C. Yeah? You can refer to that as your procedure reference, the title, and then revision. You just put revision 01 and the date of that written instruction. Okay? You want the name also? Yeah.
Mesh.
No, this one is different. This one is, oh, correct. This is blade. Blade is that one. This one is this one. Remember, you dip it.
Oh.
Yeah. Okay, then I just try and for this one, you try and use this one. Remember, you are dipping inside. This is a chemical. Just try it. This is a deep. Blade is deep. That's correct. Is it correct? The same. Okay. That's correct. D, use the D. So magnet flux ZL37. Magnet flux ZL37. Okay.
Mesh.
Batch number.
224008
Okay. Okay. For D1, you maybe just feel the top part is good. Let's move on. I show you how to do the refractometer to check our hydrophilics emulsifier concentration. You need to know how to do it. Let me just move aside because we need to open this cover. Okay. Before we use it, we need to agitate this one. Make sure it mix. Understand? Yeah. So agitation, mix around. And some of these hydrophilics container, the tank has air bubble to agitate. Yeah. So for us, we are just a small scale. We can just agitate in this manner, and then when we apply it, we just agitate with our manual hand. You follow? Let's see. Can you look at this first? Look at this refractometer through the eyepiece. You can see the scale, and all the scale is in blue color. Okay. Alright? Have you used it before?
No.
No? You used it before. Okay, not you. Never mind. Yeah. Okay, next, we need to zero it. Or we need to make sure the scale is correct by putting water. Yeah? 1 droplet of water. I just put this here, use the water here. So what I do is I put the water here, right? Ideally, you use something that is impact on that. Is that. Then you close it. When you close, make sure this one is with air bubble. Yeah. So I need to make sure I have a clear spread of the water on this prism. looks okay, but not. Yes. So this one, eyepiece, you can focus on your own eyesight. Yeah? So for me, I will focus with my glasses on, look through the right background. Yeah? Alright, so it is 0. You can see there is two sections of color behind your scale now. Just now all blue, but now the two sections, the top part is blue, the bottom part is white. And that demarcation of the two colors region is exactly at 0. If it is 0, exactly at 0, that means this refractometer is good. Otherwise, I may have to adjust at the back here. Yeah? Adjust. So if you look at it, can you agree with me? It is on the 0 scale. Yeah? 0 scale. Alright? Good. Yeah. Okay, good. Alright, next. I will dry this off. And then I ensure it's 0 properly. Then I will take one droplet, ideally with the pipette as well. Place it here. You understand? Okay, then I close it. Make sure there is no air bubble again. Right? Alright, then again I will look through. I will adjust without my glasses better because I'm nearsighted, far-sighted. Sorry. Okay, now here. 5, 6. To me, it looks like 9.5. Is it correct? Double check. What is the reading? Does it touch 10? No, right? It's below 10. Below 10. Yeah. 9.5. 9.5. Is it acceptable? 9.5? Yeah. If it is 9.5, okay, good. So you can see here this graph of refractometer reading, VS percentage of concentration. How do we build the graph? It's by mixing known percentage of volume of water and emulsifier. Can you see that? Okay. Water and emulsifier. Now you can see 5% of emulsifier I mix 95% of water, total 100 concentration is 5. And then reading of the refractometer, not necessarily 5. 6. Repeat until 20%. I've got 4 points. 4 points. Draw the best straight line. Okay, best straight line. And then now my reading of this is 9.5. This one is 5, 6, 7, 8, 9. 9.5 will be in the middle. Correct? In the middle. In the middle will be. This one is it 20? 10 division, so should be 5. A bit small for me, then you just use the pen to mark it or to point it, otherwise I cannot differentiate. Is it 10? 10, Okay, never mind, I just take half by this week. Do otherwise. Yeah, that's that. 5 will be good. Okay? Alright? Then we trace, this is 5 here, right? We trace here. 5. So now this is 2 per square. So this would be 8, and then 9, and then 9.8. 9.8. Small box to 2. So 9.8. So the concentration of this hydrophilic emulsifier is 9.8. Okay, so I use a much lower concentration. The allowed concentration is actually 20. Yeah, but our operation we use between 10. Okay, so now the actual reading is 9.8. Still below 20. I need to adjust my emulsification time. That's all. As long as I do not go beyond 2 minutes. Follow? So I will record, right, in the exercise book, practical book, my concentration is 9.8%. Can you do that? Yeah. So that is how you do the check on your hydrophilic emulsifier. Yeah, later on in the the read value is from the refractometer reading was 9.5, and then from the graph was 9.8. Remember, 9.5%. Yeah, by volume 6%. Yes, and then your graph just now we read off was 9.8. Right? That's how we record actual from the graph, not directly from the refractometer reading. Okay? If you are happy now, we need to move on to process our method D component. Our method D component. What is the requirement next? Yeah, specification is actually should not exceed the maximum percentage stipulated by the OEM. Yeah? If you look at it, they do not have a value because it depends on the manufacturer of your chemical. So just say, in this case, with this product, if you write this product name, it will be not more than 20%. Yeah? Can you do that? You must write the product name because it related to your product not more than what is mentioned by your manufacturer. For this particular product, it is not more than 20%. Specification is silent on that. They didn't mention, but they refer back to OEM says it's not more than 20%. Okay? Right. Now, if you are okay, let's move on. Let's see what I need to show you. Remember how many steps for method D? 8 steps. Yeah, 8 steps. So before we apply the hydrophilic emulsifier, we need to pre-wash. So you come here, you will pre-wash this one. Alright, make sure, okay, make sure that that's okay. For the butt of remover, then now we just switch it on. Alright, I just remove So just remove half of it. I just bring my container so that I can use it later after dipping and collecting sugar. Okay. Basically, just to remove the bulk. Alright? You want to do that? Yeah, make sure your distance and then your pressure. Water temperature, you take it at 25. Which one is yours? Yours is this one. Okay, good. Next, just put it aside first. Later we will deal once after another with the hydrophilic emulsifier waveform. Okay. Okay? Good. There's no need to be too clean because you're only removing the bulk of the excess penetrant. This is critical. Alright, next step is critical. Alright, just put it here first. This one we will do it one by one. After dipping, I have to do it within 2 minutes. Cannot exceed 2 minutes. Critical. That's why I will do it. You follow me and see how I do it. Then you will do it the likewise. Is it okay? Okay. 2 minutes. 2 minutes. So let me see how to. Stopwatch. You have a stopwatch, you just, yeah, better you have it. Okay. Okay. If it is a big item, right? As you touch the emulsifier, start. Right? So then I will stop when I have applied my first water. Yeah, correct? Alright. Now, okay, start. Okay. doing that. I just leave it there for a while, and then I will try to maybe start to wash it around 1 minute. Yeah? Okay, 1 minute. We did 1 minute. So I leave it there first. 1 minute. Imagine if you have big item, you have to pretty fast. Right? Make sure it's not too far and so on. See, this is small item, is quite straightforward. Okay, then I will just move in. It's okay, you leave it, it's okay. Continue. Yeah. So I will go in, right? So the first thing that I should do is I stop it. Apply the water. Yeah? After stop, water, you understand? So, make sure not roll up. Right? If I have the pneumatic hand, I can blow it. Otherwise, I use a tissue to rub it. If it is a simple surface like that, I just put it in the oven and install for now. Yeah? Alright. Who's next? Yeah. Want to do that? Probably cake you can start with that. Maybe I just move it. So the actual timing is not experiment. You understand? But this one we just try it at 1 minute. Reach 1 minute, you quickly start to wash to stop the hydrophilics operation. Yeah, just relax it, then you can take the time to clean. Yeah? Okay? Okay, yeah. So, yeah, cake, you can do that. You want me to press for you? When you tell me start, I will start. Okay, start. start to stop the hydrophilic action. There's a way to separate before and then you can just bring it across the way. Alright. Okay. Just put in the oven. Good. You just put it on the desk. Yeah, right there. Roughly, you know how the critical part is here. Yeah, your process is critical here. Yeah. So make sure you meet the requirement under 2 minutes. Okay. We're done with this. Now, as the part is being dry, let us move on to our method C. Make sure our glove is dry. Okay. So when your glove is dry, get some paper ready. Yeah, just take 3 pieces. Okay. Cleaner. Yeah. Probably you want to keep your your pad to there in case it may just drop the thing pad. Yeah. Okay. So remember, first of all, dry lint free. Okay. Do it under UV light. So ideally in the booth. If not, I just do it where you want to shine it. Yeah. So dry, and then just remove most of it. Okay. There is a first round. Okay. Okay, so that first white is enough. Then next will be moisten it. Okay, moisten, no drip, yeah? Moisten it, and then second one. Okay. 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 So if you have the tight fit glove, is better. Yeah. Okay. Alright, looks more or less there. Move the other side. So it's tedious, yeah? Method C is tedious. Okay. Alright. So wipe it in one direction. Don't scrub it. Yeah? If need be, you just change. Otherwise, it will recontaminate the surface. Okay. Alright. Looks okay for me. Yeah? So, can you see something there already? Yeah? Yeah, from the hole, something there. But let's see whether it's still got anything else. So I'm not concerned of this one first. Yeah, I'm just looking at one first. Right? Likewise, you can start doing yours. Yeah, you have one another. This one, I will apply the developer. Apply the developer. Probably I will apply later. Yeah, we clean, then we apply, and then we see. Right? So, yeah, okay. You want me to hold for you? You will like, or you hold it for me first, then you touch. Okay. Very good. Flat surface is easier. Yeah. Okay. Okay, you may want to moisten the tissue paper now. Okay, good. Uneven surface, so you may have to tackle it. Yeah, you may have to tackle it further because just spray somewhere and make sure at the side also you clean it. This one you don't worry, just at this within the heat affected zone. Yeah, make sure you to the side. Yes. Right? Okay, good. Alright.
Okay.
Let me just show you a bit, maybe. Just I mean, because I like this place, you just like this. You understand? Yeah, just closer to it, because otherwise it will be have plenty here. Yeah, just wipe it a bit more, then stop. Back.
Hello.
Okay. All right. Okay. Good. Just wait for developer application. Your case, let me have you. Okay, good. Okay, good. You continue with helping him to shine. Yeah. I will just take all the components from here out. Yeah. Because after some time.
Cô thêm theo có chung đưa vào bơi có mình đưa vào bơi vào phòng của mìnhไม่ถนัดช่วงนั้นได้ครั้งเดียวเปลี่ยนเนี่ยมาเอาเดน โอ้มันน่าฝนตก
มีสารนะแน่นอนเนี่ยใส่ของที่นี่ครับ
โอ้ฝนเขาเลย
Okay. Good. All right. Maybe you just this one is not area of interest, but because you want to make sure the glaring is not much. Yeah. Easier for you to interpret. You just remove it. Yeah, that's right. That's good. That's good. Okay, good. All right. Okay. Now let's bring the fish over here. Just put it here first. Kick has already applied the rubber for your letter C. But why don't you also apply your rubber on this letter T? Yeah? E. Yours is letter T. Yeah. Apply the rubber. Your rubber is bigger, yes. It's not a close. Right. That's good. Yes, that's good. Both sides. Every time hold it. Okay? Okay, maybe if you want to start with your letter C, just now you have put the developer part and you can process. For evaluation system, because the whole of this exam. Okay. They have 1, 2, confirm? Yeah? Then you can make a quick notes and then that is your.
I will let you mark.
Okay. Yeah. Emulsifier. Yes, that's right. Not enough. Can you see that? They come out with this one without emulsifier. No problem. We just run emulsifier. Is it okay? Yeah, the form was not complete because it should have emulsifier. We just put emulsifier and then what is the name, brand, batch number, and just put one number. Can you just come over here for one and panel safe? Okay. The cleaning wasn't done as well, but I can still see 1, 2, 3, 4, 5. And this is not important. So 5 means check on that picture, photograph. This is serial number 5213. 5213. Right? So 5. No problem. So this is we will use that. For intensity of your UVA line as well as your white line, just follow the yesterday number. Yeah? As long as you know how to do it, because we don't have enough time to be quick. You understand? have to write the emulsifier concentration, one more extra line. This one is 5 stacks, remember? Starbucks, 5 Starbucks. Yeah. One more is for D, your emulsifier concentration. Yeah, one more. Emulsifier chemical, and then one more here is emulsifier percentage. How much is percentage? Yeah. Extra one. You can cancel it, no problem. Left side, left side. Correct. You can cancel it and left side, cancel. You see? Yeah, it is an artificial crack, but anyway you still can detect it, correct? And see it. That's very good. method D also. Remember? Okay. You got one more test, please. Yeah, go and have a look. Otherwise, yeah, the indication may be very broad. But yeah, just check. This will have the result to you, and then you can. Okay, times check now is 3:45. Okay, you can finish your report before you leave. Yeah, maybe another 30 minutes. Once you finish, you can tidy up. Then you can be excused, return to your hotel. Yeah. Tonight, when you go back, you can read chapter 5, chapter 6, chapter 7, and chapter 8. Okay? Chapter, I write down here for you. Okay. Tonight revision, please carry out chapter 5, 6, 7. Read on your own chapter 8 as well. Okay? As we have covered 5, 6, 7, and when you go back, just explore on your own, read a bit on chapter 8. Okay, looks on. Okay, you can hand it to me, then I will mark it. Yeah, I'll pass it back to you. Just have a final review tomorrow. This one you return back to me because tomorrow I will